Have you ever been astounded by the immense magnitude of construction projects, where the limits of engineering are stretched beyond imagination and architectural marvels come to life? In this documentary, we will explore the zenith of colossal mega projects, from massive dams to the most extensive rail networks. Join us as we reveal the groundbreaking efforts that are transforming the world of construction. We move over to New York for the Hudson Tunnel project. This massive project aims to construct a new rail tunnel under the Hudson River, directly addressing the critical need for modernized and reliable rail connections between New Jersey and Manhattan. Currently estimated to cost around $11.6 billion, the Hudson Tunnel project involves constructing a new two-track rail tunnel, refurbishing the existing century-old tunnel, and making related infrastructure improvements. Upon completion in 2026, it is expected to significantly reduce the risk of severe disruptions in daily commutes and national rail transport. The new tunnel's construction is a complex challenge, requiring sophisticated tunnel boring and under-river drilling techniques to navigate the geological and environmental sensitivities of the Hudson River's underwater terrain. The existing North River Tunnel, which currently serves as the only rail link under the Hudson for Amtrak and New Jersey Transit trains, has been in service since 1910 and was severely damaged during Hurricane Sandy in 2012. The construction of the new tunnel will allow this old tunnel to be closed for repairs without disrupting the critical train services it provides. To understand the scale of the Hudson Tunnel project, consider that the new tunnel will extend about 2.5 miles under the riverbed, involving millions of cubic feet of excavated earth, enough to fill over 1,000 Olympic-sized swimming pools. The project's challenges are immense, from navigating bureaucratic hurdles and securing funding agreements across multiple government entities, to the physical difficulties of urban tunneling. It's time to move over to Switzerland for an incredibly expansive collider project. The Large Hadron Collider, straddling the Swiss-French border near Geneva, represents one of the most audacious experiments in the history of science. With a project cost of $4.75 billion, this behemoth is not only the world's largest particle accelerator, but also a centerpiece in our quest to unravel the mysteries of the universe. Envision a circular tunnel, 27 kilometers in circumference, buried up to 175 meters underground. This isn't just any tunnel, it's a superhighway where protons travel at nearly the speed of light, colliding 600 million times per second. These collisions generate temperatures a million times hotter than the center of the sun, momentarily recreating the conditions of the universe a fraction of a second after the Big Bang. The project's construction required the precision of aligning its two beams to within a hair's breadth over its 27-kilometer length. The magnets used to steer the beams are superconducting and must be cooled to minus 271.3 degrees Celsius. In 2012, the collider proved its worth by confirming the existence of the Higgs boson, often called the God particle. This elusive particle, key to the theory that explains how other particles get their mass, had remained only a theory for nearly 50 years until the collider's experiments confirmed it. But the Large Hadron Collider isn't just about particle physics. It's a hub of innovation that's propelled advances in fields like medical imaging and computing. For instance, technologies developed at CERN have led to improvements in PET scans, a crucial medical diagnostic tool. Next up, we have to look at a project that's located in between Denmark, Sweden, and Germany. The Creer's Flack offshore wind farm stands as a towering testament to Europe's commitment to renewable energy. With 72 turbines spinning over an area of 132 square kilometers, this wind farm is a crucial step toward achieving sustainability on a grand scale. The construction of Creer's Flack began with the dual aims of enhancing energy production and reducing carbon emissions across the region. Upon its completion in 2021, it became one of the largest offshore wind farms in the world, boasting a capacity to generate 600 megawatts of power. This is enough energy to supply approximately 600,000 households annually, significantly impacting the region's energy dependency on fossil fuels. The installation of each turbine at Creer's Flack was a meticulous process, involving specialized ships capable of handling the enormous weight and size of the components. Each turbine reaches up to 188 meters in height, nearly as tall as the Gherkin in London. A unique feature of Creer's Flack is its role in supporting biodiversity. Artificial reefs were created using materials from the construction to promote marine life in the Baltic Sea, showcasing an innovative approach to environmental stewardship within an industrial project. Financially, the wind farm represents a significant investment in green technology, with a total cost of $1.4 billion. This investment underscores the economic scale of transitioning to renewable energy sources, comparable in cost to constructing major infrastructure like the new Queensferry crossing in Scotland. Moreover, Creer's Flack serves as a critical junction for power connectivity in Europe. It includes an innovative feature that allows it to serve as an interconnector between Denmark and Germany, not only generating electricity but also facilitating energy trade between countries, enhancing grid stability and supply security across borders. It's time to travel to San Francisco next, where the gigantic Chase Center is one of the city's biggest mega-projects. Located in the Mission Bay neighborhood of the city, Chase Center serves as a state-of-the-art arena primarily for the Golden State Warriors, and a versatile venue for concerts and other events. This mega-project, completed in September 2019, was a private sector initiative spearheaded by the Warriors' ownership, costing an estimated $1.4 billion. Chase Center covers an area of 11 acres and includes an 18,000-seat arena, 2 office buildings, 100,000 square feet of retail space, and a public plaza. The project also involved the creation of a waterfront park along with a half-mile of restored public waterfront. One of the challenges in its development was integrating the center with San Francisco's existing public transport networks. This led to significant improvements in local infrastructure, including the addition of a Muni Metro light rail platform and the enhancement of nearby roads. The use of cutting-edge seismic technology was a focal point, considering San Francisco's susceptibility to earthquakes. This included innovative base isolators and shock absorbers that ensure the arena can withstand significant seismic events. Chase Center's unique architectural design and construction methods included the use of sweeping glass facades and intricate metalwork that complements the bay's maritime setting. If you consider the height of the arena at nearly 135 feet, it stands tall enough to house the Statue of Liberty inside it, giving a sense of the scale at which this construction was conceptualized and executed. Next up, it's time to travel to New York for the Bayon Bridge raising project. This development is an extraordinary engineering feat located over the Kill-Van-Kull Strait, connecting Staten Island, New York, to Bayonne, New Jersey. This project was initiated to address the critical need for modern cargo ships to access the ports of Newark and Elizabeth, New Jersey, which are among the busiest on the eastern seaboard. The original bridge, completed in 1931, had a navigational clearance that was too low for the new generation of ultra-large container vessels introduced with the expansion of the Panama Canal. Completed in 2019, the project successfully raised the bridge's roadway from 151 feet to 215 feet above the water level, while also maintaining the iconic arch design. This adjustment made it possible for ships nearly twice the size of those previously accommodated to pass underneath, significantly increasing the operational capacity and efficiency of the port facilities. The project cost was approximately $1.7 billion, reflecting both its scale and complexity. One of the significant challenges was executing the work without disrupting the heavy vehicular traffic on the bridge, which necessitated innovative construction methods and careful scheduling. In terms of its engineering methodology, the project was notable for its use of the raise the roadway technique. This method involved building a new roadway above the existing one while traffic continued below, and then removing the lower roadway upon completion. Comparing the scale of the Bayon Bridge project to other engineering projects, its new 215 feet clearance is high enough to accommodate an NFL football field standing on end. The Bayon Bridge raising faced numerous challenges during its execution, including technical difficulties inherent in working with existing structures, the need to maintain stringent safety standards, and the unpredictable weather conditions over the strait. The project also had to navigate complex regulatory and environmental approvals, coordinating with multiple governmental bodies and community stakeholders to mitigate impacts on the surrounding areas. Let's travel to Los Angeles for the LAX International Airport modernization project. The initiative is slated for completion in 2028 prior to the Olympic Games and is currently one of the most significant infrastructure undertakings in the United States, with a budget exceeding $14 billion. Spanning over 1,700 acres, the airport project aims to accommodate increasing passenger numbers, projected to rise to over 100 million annually by the end of the decade. This extensive modernization includes the construction of new facilities, enhancement of existing structures, and the introduction of innovative transport systems. The project involves the addition of more than 3 million square feet of terminal space, effectively increasing the airport's size by 25%. This addition is equivalent to about 42 football fields laid side by side. The centerpiece of the project, the midfield satellite concourse, alone spans 750,000 square feet, featuring 12 new aircraft gates. Additionally, the project features a centralized utility plant upgrade that employs 6,000 solar panels and an advanced water reclamation system, which together aim to cut energy consumption by up to 25%. Challenges faced during this vast project include maintaining airport operations during construction. Solutions have involved intricate phasing of construction activities and the use of real-time analytics to manage flow and logistics across the sprawling site. Next up, we have to talk about one of the most expensive electrical projects in Europe, called the Viking Link project. This is an ambitious power connection project stretching over 760 kilometers between the United Kingdom and Denmark. Its primary aim is to enhance the security and sustainability of energy supply by enabling the transfer of up to 1,400 megawatts of electricity between the two countries, enough to power approximately 1.4 million homes. Initiated in 2020, this project is pivotal in fostering energy cooperation across borders. The construction involves laying submarine and underground cables from Revsing in Denmark to Bickerfen in Lincolnshire. These cables are engineered to withstand harsh marine environments and provide a reliable conduit for electricity over decades. The technology used in the Viking Link incorporates high-voltage direct current systems, which are more efficient over long distances than the more common alternating current systems. Addressing challenges such as environmental impact and technical complexities, the project required meticulous planning and consultation with marine biologists to minimize disruption to marine life. Additionally, engineers faced the technical challenge of routing cables through varied terrains, including the North Sea's challenging seabed. The project also incorporates cutting-edge converter stations at each end, which are crucial for converting electricity between DC used in transmission and AC used in domestic power grids. With a total cost of $1.92 billion, this project represents a major investment in sustainable infrastructure. But what about the most expensive megaproject located in Europe? High Speed 2 is poised to be one of the most transformative rail projects in European history, designed to connect London with the north of England and potentially the central belt of Scotland. The project's primary objective is to enhance connectivity, reduce travel times between major cities, and alleviate congestion on the UK's existing rail network. Initiated with the intention to drastically reduce travel times, HS2 will see trains operating at speeds of up to 250 miles per hour. Upon its anticipated completion, the journey from London to Birmingham will be cut to just 45 minutes, compared to the current duration of an hour and 20 minutes. The project will lay down hundreds of miles of track, which requires the excavation and movement of millions of tons of earth. The project scale is mirrored by its workforce requirements, with tens of thousands of jobs expected to be created during construction. Additionally, HS2 is a catalyst for technology and innovation in construction, employing advanced techniques in tunneling, bridging, and environmental conservation. The trains are planned to be powered by zero-carbon energy from day one of operations, aligning with the UK's broader environmental goals. The new rail lines themselves are designed to integrate with the natural landscape, incorporating green tunnels and wildlife crossings to minimize the environmental impact. However, HS2 has faced considerable problems and controversies, particularly regarding its cost and the environmental impact of its construction. With its budget now revised to an estimated $130 billion, HS2 ranks as the most expensive infrastructure project undertaken in Europe. This investment underscores the UK government's commitment to revolutionizing transport, but has also sparked debates on fiscal responsibility and environmental stewardship. Despite these challenges, the potential benefits of HS2 are substantial. It is expected to double the number of seats available out of London Euston, reducing road congestion. It's time to travel to the state of Texas, where Tesla's Gigafactory is located. This sprawling facility, initiated in July 2020, underscores Tesla's commitment to scaling up its production capabilities, particularly for the Tesla Cybertruck and Tesla Semi. Occupying over 2,500 acres along the Colorado River, Giga Texas is designed to be an eco-friendly facility, integrating closely with the surrounding environment. The site is one of the largest buildings in the world by footprint, featuring approximately 10 million square feet of operational space spread over several floors. This size equates to about 172 football fields, providing a visual of the vast scale of this project. The total investment by Tesla into this project is expected to exceed $1 billion, which is anticipated to inject significant economic activity into the local and state economy through direct employment and ancillary benefits to suppliers and service providers. Giga Texas is pivotal in solving the logistical challenges associated with Tesla's supply chain, aimed at reducing shipping costs and production bottlenecks. It is set to become a critical hub for Tesla's operations in the eastern United States, enhancing the company's distribution logistics across the East Coast and international markets. The factory's location was strategically chosen for its proximity to rail and road networks, facilitating efficient material shipments and distribution of finished vehicles. But what about one of the tallest skyscrapers in New York City? Located in the bustling Hudson Yards district of Manhattan, the Spiral Tower stands as a pinnacle of architectural innovation and modern design. Officially known as 66 Hudson Boulevard, this towering skyscraper reached its completion in 2022, emerging as one of the most distinctive profiles against the NYC skyline due to its spiraling green terraces that ascend with the building's rise. The spiral spans 65 stories, measuring approximately 1,041 feet in height. The project carried a substantial financial commitment, with development costs estimated at around $3.7 billion. The construction of the spiral employed approximately 7,600 workers across various phases, reflecting its scale and the complexity of its design. This architectural marvel was conceived to offer a blend of premium office spaces and expansive green outdoor terraces on each floor, integrating nature into the urban workspace. Each terrace is equipped with foliage and seating areas, providing accessible outdoor space to office occupants, a rare feature in Manhattan's dense urban landscape. The construction of the spiral involved innovative building techniques, particularly in the integration of its steel superstructure with the cascading terraces. Advanced computer modeling and precision fabrication were crucial to ensuring that each floor's outdoor space seamlessly aligns with the spiraling design. The spiral's total floor area is about 2.8 million square feet, roughly equivalent to the size of 50 football fields. However, the project wasn't without challenges. Its construction phase coincided with the pandemic, which posed significant logistical challenges, delaying materials and reducing workforce efficiency due to health and safety protocols. Yet, the project team adapted with enhanced safety measures and scheduling adjustments to mitigate these impacts. But what about a massive dam megaproject? For that, we have to travel to the Ohio River, where the Alstad Locks Dam project is located. This monumental undertaking, designed to replace aging infrastructure and modernize the waterway system, is crucial for the transportation of billions of dollars worth of goods annually across central U.S. This project, which officially completed in 2018 after over 30 years of planning and construction, spans across the river and involved an extraordinary financial investment of approximately $3 billion. The construction required the sustained effort of hundreds of engineers, technicians, and laborers over several decades, underscoring the project's scale and complexity. The Alstad project replaced two older and less efficient facilities, locks and dams 52 and 53, which had become increasingly unreliable, causing significant delays in river traffic and logistical inefficiencies. The new structure consists of a navigational pass and two parallel 110 feet by 1,200 feet locks. This setup significantly eases the river traffic, allowing for the smooth passage of approximately 90 million tons of cargo yearly. One of the notable challenges of the Alstad Locks and Dam was its innovative construction method, specifically the use of in-the-wet technology. Unlike traditional dry dock methods, this technique involves assembling large modular sections of the dam on land, then floating them to their installation site on the river. The total amount of concrete used in the dam's construction would be enough to pave a sidewalk stretching from New York to San Francisco. A special feature of the Alstad Locks and Dam is its resilience to seismic activity. The region is near the New Madrid fault line, and as such, the structure was designed to withstand significant earthquakes, ensuring the long-term stability and safety of this critical infrastructure. The project's importance extends beyond just its immediate functionality. By improving the reliability and efficiency of the Ohio River as a navigational channel, the Alstad Locks and Dam also bolsters the economic viability of river transportation, which is significantly more fuel efficient and environmentally friendly compared to road and rail transport. We have to talk about a massive pipeline project that crosses multiple European countries. The Trans-Adriatic pipeline represents a groundbreaking stride in European energy infrastructure, stretching 878 kilometers from the Greek-Turkish border through Albania and into Italy. Completed in 2020, the pipeline is a key segment of the Southern Gas Corridor, a strategic initiative to reduce dependence on Russian gas by bringing new sources to European markets. The project taps into the vast gas fields of Azerbaijan, specifically the Shah Deniz field, which holds an estimated 1.2 trillion cubic meters of gas. Constructing the pipeline was a feat of engineering and environmental planning. The pipeline crosses diverse terrains and climates, from the plains of Greece to the rugged mountains of Albania and the depths of the Adriatic Sea. Each segment poses unique challenges, such as in Albania, where the pipeline ascends to an altitude of over 2,100 meters before descending to sea level, a feat akin to laying a pipeline across the height of Mount Kilimanjaro. The project navigated delicate ecosystems and densely populated areas with minimal disruption. Advanced horizontal directional drilling was used to install sections of the pipeline beneath sensitive areas, avoiding surface disturbance to habitats and human settlements. This project required an immense investment of $4.8 billion, which is a similar cost compared to the new Berlin-Brandenburg Airport. The pipeline's specialty lies in its operational technology, including state-of-the-art compressor stations in Greece and Albania that are capable of reversing flow, meaning that Europe can either receive or send gas depending on supply and demand dynamics. But how about a barrier megaproject that will protect an entire city? Venice, a city renowned for its unique architecture and intricate waterways, has been facing an existential threat from flooding due to rising sea levels and sinking foundations. In response, Italy embarked on one of the most ambitious and technically complex engineering projects in Europe, the Venice Flood Barrier, officially known as the Moat project. Initiated in 2003, the project comprises a series of 78 mobile underwater gates designed to temporarily isolate the Venetian lagoon from the Adriatic Sea during high tides. Spanning 3 inlets that connect the lagoon to the sea, each gate measures 20 meters wide and weighs up to 300 tons. When not in use, these gates rest in caissons on the seafloor, filled with water. During high tides, air is pumped into these caissons, causing the gates to rise and block the incoming water. The technical challenges of constructing such a system were immense. Engineers had to develop new materials and methods to ensure the gates could withstand the harsh marine environment, including building special corrosion-resistant barriers that could endure for decades. The project also involved massive dredging operations to lay the foundations of the gates, moving millions of cubic meters of seabed. But besides those challenges, delays and cost overruns were frequent as well, pushing the project's completion date several times. The initial budget ballooned from an estimated $1.6 billion to an eventual total of $5.7 billion, making it one of the most expensive megaprojects in Europe. Unlike conventional dams or levees, the Venice flood barrier is designed to be both invisible and temporary, appearing only when needed to protect the historic city. Let's travel to the United Kingdom next for the Hinkley Point C Power Station. This project, which broke ground in 2016, aims to provide a secure, low-carbon energy source capable of powering approximately 6 million homes. The Hinkley Point C project is the first new nuclear power station to be built in the UK in over 20 years. Upon completion, it will house 2 European pressurized reactors, each expected to deliver 1,630 megawatts of power. The significance of this development extends beyond energy generation. It's a critical move towards sustainable industrial growth and job creation. The construction of Hinkley Point C has brought together a workforce of around 25,000 over its lifespan. The project site spans 430 acres, and the volume of concrete to be used in the construction is projected to be enough to fill 75 football stadiums. Technologically, Hinkley Point C employs advanced safety and operational features, including a robust cooling system and state-of-the-art security measures to ensure safe, continuous operation. The design also incorporates lessons learned from previous nuclear developments, making it one of the safest and most efficient nuclear power plants globally. Challenges faced during the project have been substantial. These include regulatory hurdles, financial negotiations, and public opposition based on safety concerns. Moreover, the project's timeline has been impacted by the intricate nature of nuclear construction and the need for rigorous inspection and quality control to meet stringent nuclear safety standards. Economically, the investment in Hinkley Point C is significant, with costs estimated at around $43 billion. This makes it one of the most expensive energy projects ever undertaken, comparable in cost to the creation of vast urban developments. Hinkley Point C's strategic importance is underscored by its projected output, which will provide about 7% of the UK's total electricity needs with reliable, low-carbon energy. This is crucial for a country aiming to phase out coal by 2024 and reduce greenhouse gas emissions significantly by 2050. Up next, it's time to investigate the Goebels Bridge. This project is a significant architectural feat in the United States, linking Elizabeth, New Jersey to Staten Island, New York. The bridge was originally constructed in 1928 and underwent a massive rebuilding project that began in 2014 and concluded with the opening of its eastbound span in 2018. The total project cost was approximately $1.5 billion, highlighting its scope and the investment required to modernize critical infrastructure. Designed to replace an aging structure that could no longer efficiently handle modern traffic volumes, the new Goebels Bridge features twin spans, each supporting 3 lanes of traffic, additional shoulders, and a pedestrian and bike pathway that will be completed in a future project phase. One of the most notable methods used was the modular construction approach. Large segments of the bridge were prefabricated off-site and then transported to the location for assembly. This method not only sped up the construction process, but also minimized environmental impact and disruption to the existing traffic. The Goebels Bridge project was a technical challenge, involving the installation of 60 feet tall piers and the lifting of massive 900-ton segments into place. The bridge spans a total length of 1.4 miles, with each of the twin spans stretching approximately 900 feet in their longest span section, requiring precision engineering and construction expertise. One unique aspect of the Goebels Bridge is its focus on sustainability. The project included measures to protect the local marine environment and featured the extensive use of recycled materials. Moreover, the bridge's design incorporates energy-efficient LED lighting and has provisions for future smart transportation technologies. But what about the redevelopment of an entire train station? That's what happened with New York's Moynihan Train Hall. This grand project, completed in January 2021, seamlessly blends state-of-the-art facilities with historic architectural elements. The project cost approximately $1.6 billion, a strategic investment aimed at reviving the Midtown area and providing New York commuters and travelers with a more dignified and spacious environment. Construction of the train hall was a logistical challenge, requiring the coordination of thousands of workers in a densely populated urban area. The workforce fluctuated throughout the project, peaking at around 1,200 workers during its most intense phases. These individuals were involved in intricate tasks ranging from restoring the century-old steel trusses to integrating modern technology and security systems within the structure. The Moynihan Train Hall solves several pressing problems associated with the original Penn Station: overcrowding, lack of natural light, and limited amenities. By expanding into the Farley building, the project has effectively increased the station's total footprint, allowing it to serve up to 700,000 passengers daily. The hall's design features a dramatic 92 feet high skylight that arches over the main concourse. This skylight, covering an area of 31,000 square feet, not only illuminates the space with natural light, but also serves as a modern counterpoint to the Farley building's Beaux Arts facade. We travel to France next for a gigantic canal megaproject called the Seine-Nord-Europe Canal. Designed to connect the Oise River at Campigny to the Dunkirk-Escaut Canal near Cambrai, this ambitious canal extends over 107 kilometers, providing a high-capacity waterway link between Paris and major northern European ports. Slated for completion in 2028, the canal aims to alleviate road and rail congestion by providing an eco-friendlier option for cargo transport. The canal is expected to support vessels up to 4,400 tons, double the capacity of most existing barges in the region. This increase not only maximizes cargo volumes, but also drastically reduces the environmental impact per ton of goods transported, aligning with broader European sustainability goals. The construction of the canal involves extensive earthworks, with an estimated 50 million cubic meters of soil to be excavated. This volume of soil is enough to fill the Great Pyramid of Giza approximately 5 times over. Furthermore, the project will include the construction of 3 massive locks, each capable of lifting vessels up to 13 meters high, akin to navigating a 4-story building vertically through water. In addition to the primary waterway, the project includes the creation of 55 structures, including aqueducts and bridges, to maintain the cross-connections between divided regions and to ensure that local ecosystems and communities remain intact. The workforce on this project is tasked not only with the physical construction, but also with implementing advanced hydroengineering techniques to manage the water flow and ensure safety during the canal's operation. One of the most innovative aspects of the Seine-Nord-Europe Canal is its incorporation of smart technology. The canal will feature automated lock systems and remote-operated bridges, enhancing operational efficiency and safety. This technological integration positions the canal as a future-proof infrastructure ready to handle the anticipated increase in automated and digital shipping processes. With a total cost of $5 billion, the Seine-Nord-Europe Canal is comparable in ambition and budget to other major infrastructure projects like London's Crossrail project. Moving over to Chicago, we have to talk about the Lincoln Yards megaproject. This expansive plan, spearheaded by Sterling Bay, is a $6 billion redevelopment plan that is reshaping over 55 acres of former industrial land into a vibrant, mixed-use complex. Upon its phased completion, with projections spanning the next decade, Lincoln Yards aims to serve as a new epicenter for residential living, commercial activity, and cultural flourish in Chicago. A pivotal element of Lincoln Yards is its promise to create upwards of 24,000 full-time jobs during its construction phases, involving a vast array of trades and specialties. At its core, Lincoln Yards is designed to address the pressing need for urban revitalization and connectivity between Chicago's northwestern neighborhoods, effectively bridging a gap that has long segmented the city. The development encompasses over 14 million square feet of buildings, including high-rise residential towers, office buildings, and an array of retail spaces. One of the major challenges Lincoln Yards faces is integrating this vast new development seamlessly with existing infrastructure. The plan includes substantial improvements to local transit systems, including a new metro train station, multiple new bridges over the Chicago River, and enhanced pedestrian and bike paths to ensure accessibility and reduce traffic congestion. An ambitious aspect of the Lincoln Yards project is the proposed Live Nation Entertainment District, which will include multiple venues for concerts and cultural events, capable of hosting thousands of visitors. This entertainment component is envisioned to be comparable in scale to London's O2 Arena district, albeit integrated within a larger mixed-use development. But how about an entire stadium being replaced? The Aloha Stadium Replacement Project, located in Aloha, Hawaii, is a significant undertaking aimed at revitalizing the sports and entertainment capabilities of Hawaii's most populous island, Oahu. This ambitious project replaces the aging Aloha Stadium, originally built in 1975, which had become increasingly costly to maintain and no longer met modern safety or functionality standards. Scheduled for completion in 2028, the new stadium complex is anticipated to cost over $350 million. The project covers an extensive area of approximately 98 acres, with the new stadium expected to seat around 35,000 spectators, down from the old stadium's capacity but designed to offer improved sightlines and amenities. This size makes it comparable to the StubHub Center in California, though with enhanced technological integrations. Employing around 2,000 workers during peak construction phases, the project faces the unique challenges of building in an island setting, such as logistics complications related to material shipping and the high cost of labor and supplies in Hawaii. The new stadium will employ modern construction techniques, including the use of sustainable materials and energy-efficient designs to minimize its environmental footprint. Features like solar power generation and water reclamation systems are planned to make it one of the greenest stadiums in the nation. A key problem that the new Aloha Stadium aims to solve is the economic inefficiency of its predecessor. The old stadium was underutilized, partially due to its deteriorating condition and lack of modern facilities that limited event hosting capabilities. The new complex, with its state-of-the-art features, seeks to attract more high-profile events and, consequently, generate significant economic benefits for the region. One innovative aspect of the project is its integrated approach to development. The stadium complex will include mixed-use developments such as hotels, retail spaces, and residential areas, creating a vibrant community hub rather than just a sports venue. This model follows the trend seen in projects like the Atlanta Braves' Truist Park, which integrates a stadium with a larger commercial and residential district. We have to talk about the 2nd Avenue subway megaproject next, located in New York City. Officially part of the Metropolitan Transportation Authority network, this new subway line runs along 2nd Avenue on the east side of Manhattan. The project has been in the conceptual and developmental stages since 1920, but saw its first phase completed and opened to the public on January 1, 2017. Phase 1 of the 2nd Avenue subway cost approximately $4.45 billion and included 3 new stations with a new terminal at 96th Street. The construction of the 2nd Avenue subway involved approximately 6,000 workers at various stages, tackling complex urban engineering challenges such as tunneling beneath densely populated areas and avoiding disruptions to the existing utility infrastructures. This necessitated the use of tunnel boring machines, which are sophisticated pieces of equipment that can efficiently cut through New York's bedrock while minimizing vibrations that could damage building foundations above. The 2nd Avenue subway covers a planned total length of 8.5 miles, once all phases are complete. To put the scale of this project into perspective, the total length of the new subway line would be equivalent to more than 146 football fields laid end-to-end. Each station is built with expansive, column-free platforms and high ceilings to enhance passenger comfort and safety, a notable departure from many of the city's older subway stations. The 2nd Avenue subway has faced numerous challenges, including budget overruns and delays primarily due to the complexities of constructing a new subway line in one of the world's most built-up urban environments. Comparatively, the cost and scope of the 2nd Avenue subway are similar to those of the Crossrail project in London, although the latter is even larger in scale. But what about the construction of a gigantic port? The London Gateway Port, strategically positioned on the north bank of the River Thames, is the United Kingdom's premier deep-sea port and Europe's most advanced logistics hub. Opened in 2013, this sprawling facility covers over 1,500 acres, equivalent to more than 1,000 football fields. It boasts 6 deep-water berths and has the capacity to handle the world's largest container ships, which can carry up to 18,000 containers each. This capability is crucial in accommodating the ever-increasing size of global shipping vessels and maintaining the UK's competitive edge in international trade. The construction of London Gateway involved over 10,000 workers at peak times, drawing on a range of specialties from marine construction to high-tech automation. The port utilizes some of the most advanced cranes and automated stacking cranes in the world, all designed to minimize cargo handling times and maximize efficiency. One of the significant challenges faced during the construction was maintaining strict environmental regulations. The project included creating a new 1,500-acre wildlife reserve as part of its commitment to biodiversity, which serves as a habitat for bird life and other species, thereby balancing industrial development with environmental conservation. A special feature of the port is its ability to function as a tidal port, which maximizes accessibility for shipping regardless of tidal movements. This feature is crucial for maintaining constant flow and operation, distinguishing it from other ports that may face operational delays due to tidal constraints. The investment in London Gateway Port of $1.87 billion mirrors the financial commitment seen in projects like the expansion of Barcelona's El Prat Airport, another critical infrastructure aimed at boosting capacity and economic growth. But how about one of the most impressive underground rail projects in Europe? The Jubilee line extension initiated in the mid-1990s and opened in phases between 1999 and 2000. This extension added 16 kilometers to the Jubilee line, stretching from Green Park to Stratford and including 11 new stations. This project tackled the acute need for improved transit solutions in underserved areas of East London and supported the regeneration of numerous boroughs along its route. Each station is uniquely designed, with Canary Wharf Station being one of the largest, enclosed in a vast glass dome and supporting a daily footfall in the hundreds of thousands. The extension was not just about adding track. It involved sophisticated engineering challenges, particularly in constructing deep-level tunnels beneath some of the most densely developed parts of the city. A workforce of over 3,000 people was engaged, with a peak of 2,000 workers underground during the height of construction. The logistics of moving such numbers in and out of confined spaces safely and efficiently was a testament to the meticulous planning and execution of the project managers. One of the most notable features of the Jubilee line extension is its integration of art and architecture within the public transport system. Each new station features works by different artists, making the line a cultural tour as much as a transit route. On the technical front, the extension required laying down enough concrete to fill 30 Olympic-sized swimming pools and enough steel to build 2 Eiffel Towers. The challenges were manifold, including financial overruns and delays that pushed the final cost to $4.3 billion, a figure that reveals the complex nature of urban underground construction. For the next project, it's time to move over to Belgium. The LNG terminal Zebr is strategically positioned at the crossroads of maritime routes that link Northern Europe with LNG-producing regions, including Qatar and the United States. The facility serves as a critical reception point for liquefied natural gas, which is then regasified and fed into the European gas grid. This project, initiated with an eye on the future energy landscape, features state-of-the-art technology including LNG storage tanks and regasification units. These tanks are massive, each with a capacity to store up to 180,000 cubic meters of LNG, roughly equivalent to 72 Olympic-sized swimming pools per tank. The terminal's regasification capability stands at an impressive rate, able to process billions of cubic meters of gas annually, directly feeding into Europe's energy network. The completion of the terminal is set for 2026, aiming to address one of Europe's most pressing problems, energy dependency. By increasing the number of entry points for LNG into Europe, the terminal not only diversifies the energy supply but also stabilizes it, making it less susceptible to geopolitical fluctuations that can affect natural gas pipelines from traditional sources. With a total investment of $1.2 billion, this project aligns with the likes of the Fehmarn Belt fixed link between Denmark and Germany. The specialty of the Zebr project isn't just in its operational capabilities, but also in its design and environmental considerations. Featuring advanced vapor recovery systems, the terminal minimizes environmental impact by capturing and reliquefying gas that evaporates during operations, showcasing a commitment to sustainable practices in industrial design. It's time to go to Germany next, where Stuttgart 21 is being constructed. This project is a visionary rail and urban development project that fundamentally transforms Stuttgart's transport infrastructure and urban landscape. Initiated with construction in 2010, Stuttgart 21 is one of the most complex rail projects in Europe. It involves the excavation of 57 kilometers of new tunnels and the construction of 25 kilometers of new rail lines. The scale of earth moved in this project is staggering, enough to fill several thousand Olympic-sized swimming pools. This involves intricate engineering to handle and dispose of materials while ensuring stability for new and existing structures. Additionally, the project includes the redevelopment of 100 hectares of land in the city center, which will provide space for new homes, parks, and commercial areas once the rail lines are underground. The project has faced numerous challenges since its inception, including public protests and escalating costs. Originally estimated at around $4.5 billion, the budget has since ballooned to approximately $9.8 billion, making it one of the most expensive infrastructure projects in Europe. The increase in costs and the time required to manage such a massive undertaking have been points of contention and public debate. Despite these challenges, the benefits of Stuttgart 21 are projected to be significant. The new station will reduce travel times, increase train capacity, and improve connectivity between Stuttgart and major European cities. It's expected to enhance local and regional economic development and reduce traffic congestion in Stuttgart's city center. Approximately 5,000 workers are involved in this project, employing cutting-edge construction techniques and technologies. For instance, the use of slab track, a type of railway track that provides a consistent and stable base, is a key feature in modernizing the railway system. Comparatively, the total cost of $9.8 billion reflects a financial scale similar to that of constructing the new Terminal 5 at London's Heathrow Airport, underscoring the significant investment required for state-of-the-art infrastructure projects. It's time to travel to Germany, where the RASAT Tunnel is located. This underground endeavor aims to improve the European rail network, specifically designed to alleviate the strain on existing rail routes and significantly enhance cargo and passenger travel efficiency between Karlsruhe and Basel. The RASAT Tunnel stretches over a length of 4,270 meters, and it will end up costing around $1.2 billion. Construction kicked off in 2016. But it hasn't been without its challenges. In 2017, a significant setback occurred when part of the tunnel collapsed, causing extensive delays and requiring a reevaluation of project strategies and safety measures. Approximately 2,000 workers have been involved in this mega project, utilizing state-of-the-art construction methods such as tunnel boring machines that carve through the earth with precision. The tunnel features twin tubes, each 10 meters in diameter, which is about as wide as 3 cars parked side by side. These massive tubes are designed to handle the increased rail traffic, with an expected completion and operational date set for 2026. Material-wise, the project is a showcase of modern engineering, using thousands of tons of steel and concrete to ensure structural integrity and safety. In terms of problem solving, the tunnel is a crucial component in the larger strategy to create a more cohesive and efficient European transit network. Let's investigate a massive nuclear plant megaproject next, called Olkiluoto Nuclear Plant Unit 3. Launched with the aim of significantly bolstering Finland's energy independence and reducing carbon emissions, the project has taken on monumental proportions in both scope and budget. Construction of Olkiluoto 3 began in 2005, with the initial goal of completion by 2009. However, a series of technical challenges, regulatory hurdles, and construction delays pushed its anticipated operational start to 2023. The reactor is of the European pressurized reactor type, which is among the most advanced and safest nuclear reactor designs available, incorporating a multitude of redundant safety systems and modern technology to enhance its operational efficiency. This unit alone adds about 1,600 megawatts of capacity to Finland's power grid, enough to power roughly 1.3 million homes. The technical complexities of building a reactor of this sophistication have necessitated innovations in construction methods, including the use of massive concrete pours that ensure the reactor's durability and resistance to any external shocks. One of the notable features of the Alcalaudo 3 project is its containment building, designed to withstand extreme external events like aircraft impacts and natural disasters, setting a new standard in nuclear safety. The volume of concrete and steel used in this project is staggering, with the containment building alone using steel reinforcement that could stretch from Helsinki to Stockholm if laid end to end. Financially, Alcalaudo 3 has been a behemoth, with costs escalating to an estimated $12 billion. This figure places it among the most expensive energy projects in the world, not just for its sheer scale but also for the complexity and pioneering technology it embodies. Each delay in the timeline not only added to the cost but also served as a lesson in international engineering projects' complexity, especially in an industry as regulated and safety-focused as nuclear power. It's time to move over to Boston now for the Green Line Extension megaproject. This extension aims to enhance public transit services by connecting the densely populated but underserved areas of Somerville and Medford to the existing subway network, thereby increasing accessibility to central Boston. Launched with major construction efforts ramping up around 2018, the GLX project completed in 2023. The project's budget, initially estimated at $2 billion, saw an increase to nearly $2.3 billion due to unforeseen construction and environmental challenges. Spanning approximately 4.7 miles, the GLX adds 7 new stations along 2 branches, one terminating at Union Square in Somerville and the other at Tufts University in Medford. These new tracks and stations are expected to serve about 45,000 riders daily, significantly easing traffic congestion and reducing commute times in these high-density corridors. The workforce required for this mammoth project varied throughout its phases, involving up to 1,000 construction workers and engineers at peak times. One of the most critical problems the GLX project addresses is the reduction of vehicle emissions by providing a reliable and efficient public transit alternative, thereby contributing to the state's environmental goals. In terms of construction, the GLX employed advanced methods including the use of track-laying machines that allowed for faster, more efficient installation of rail lines. This project also involved substantial upgrades to existing infrastructure, such as the improvement of bridges and roads along the extension path, ensuring that the new service would be integrated smoothly with minimal disruption. Challenges encountered during the GLX project included managing complex logistics in densely populated areas, mitigating noise and disruption to local communities, and addressing cost overruns and delays, which were exacerbated by the pandemic. It's time to investigate the London Array offshore wind farm next. This colossal project, operational since 2013, spans an area of 100 square kilometers, roughly the size of 14,000 football fields, making it one of the largest offshore wind farms in the world. Comprising 175 turbines, each towering up to 147 meters high, the London Array has a peak capacity of 630 megawatts. This enormous output is capable of powering nearly 500,000 homes, significantly contributing to the UK's renewable energy targets. The installation of turbines in a marine environment posed complex challenges, from logistical hurdles in transporting massive components by sea to installing them on the seabed amidst varying weather conditions. The project also necessitated the laying of over 200 kilometers of underwater cables that connect the turbines to each other and to the power grid onshore. Safety and environmental sustainability were paramount throughout the construction phase. Innovative measures were implemented to protect the local marine ecosystem, including the use of bubble curtains, a technique that minimizes the impact of underwater noise on marine life during pile driving activities. The scale of the London Array can be likened to that of the Hoover Dam in terms of electricity output, although the technologies and the environments they harness are vastly different. The investment of $2.35 billion into this project places it among the titans of European mega-projects. Let's travel over to North Carolina, where the Charlotte Gateway Station is being constructed. This significant development, a central hub designed to integrate various modes of transportation including Amtrak, buses, and future light rail services, is part of a larger vision to improve transit connectivity across the region. Scheduled for full operational status by 2025, The Charlotte Gateway Station began its early phases in 2018 with a budget projected to exceed $800 million by the project's conclusion. The station itself will cover several city blocks, featuring a state-of-the-art passenger terminal, bus bays, and extensive parking facilities. The project's total area is comparable to 20 football fields, emphasizing its scale and the transformational impact on the city landscape. It is expected to serve thousands of passengers daily, significantly easing the city's traffic congestion and providing a more efficient, reliable public transportation network. One of the primary challenges has been coordinating the multiple phases of construction while minimizing disruptions to the existing traffic and businesses in downtown Charlotte. The station's design features include expansive glass facades to maximize natural lighting and open public spaces that encourage pedestrian traffic, reflecting new trends in urban station aesthetics and functionality. In comparison to other transportation projects like the Moynihan Train Hall in New York City, the Charlotte Gateway Station is unique in its incorporation of green building practices and its role in catalyzing economic development in a mid-sized American city. Despite challenges such as budget adjustments and the complex logistics of constructing in a dense urban core, the Charlotte Gateway Station is set to become a critical node in North Carolina's transportation network. Next up, we have to talk about the Atlanta Beltline project. Envisioned as a comprehensive revitalization effort, the Beltline aims to convert a historic 22-mile railroad corridor encircling downtown Atlanta into a multi-use trail, modern streetcar line, and expansive green space. This grand project, which began in the early 2000s and is expected to continue in phases through 2030, is not only redefining urban transit, but also enhancing community connectivity. With an estimated cost exceeding $4.8 billion, the Atlanta Beltline is one of the largest, most wide-ranging urban redevelopment projects in the United States. It involves the coordination of multiple city departments and private contractors, engaging thousands of workers over its multiple phases of development. The Beltline addresses several critical urban challenges, including the need for improved public transportation options. By connecting 45 in-town neighborhoods with multi-use trails and transit options, it promotes a more sustainable lifestyle, reducing reliance on automobiles and encouraging walking, biking, and public transit. A notable feature of the Atlanta Beltline is its use of existing railroad tracks for the trail and transit system. The project has faced challenges, particularly in terms of funding and community engagement. Balancing the diverse needs and expectations of various stakeholders, residents, and city officials has required continuous dialogue and adaptation. Additionally, the Beltline has navigated complex logistical challenges associated with constructing and maintaining infrastructure across active urban environments without significant disruptions to the daily lives of Atlanta's residents. One of China's proudest achievements are their bridge construction projects. Therefore, we're paying a visit to the Qishu River Bridge, officially completed and opened to the public in 2019. This architectural marvel spans the Qishu River in Qishu province, seamlessly connecting the cities of Zhishui and Guilin. The bridge is part of a broader initiative to improve transportation links in the mountainous regions of southwest China, significantly reducing travel time between these cities from over an hour to just a few minutes. The Qishu River Bridge is noteworthy for its status as one of the highest bridges in the world. It rises approximately 304 meters above the river, with a total length of 1,280 meters, making it a significant achievement in China's bridge construction. The bridge's design follows a rigid frame type, with a span configuration that includes a large central span flanked by smaller approach spans, a design choice that optimizes both the structural integrity and the aesthetic appeal of the bridge. Construction of the Qishu River Bridge was a monumental task that required precise planning and execution. The project's total cost amounted to $236 million, a reflection of the extensive resources, labor, and materials invested into its realization. The construction phase involved the use of cutting-edge machinery and technologies, including high-strength concrete and steel, to ensure the bridge's ability to withstand the environmental challenges presented by its location. One of the most challenging aspects of the bridge's construction was the terrain of the Qishu River Valley itself. The steep and uneven landscape necessitated innovative construction methods, including the use of advanced cable crane systems to transport materials across the valley. The Qishu River Bridge not only serves as a vital transportation link, but also as a testament to the advancements in modern Chinese engineering and construction techniques. The next project on our list is a tunnel that's connecting two major countries, the Fehmarn Belt Fixed Link. This ambitious project, with an estimated cost of 7.4 billion euros, is not just another infrastructure endeavor. It's a bold leap towards uniting regions and enhancing mobility in Europe by connecting Germany and Denmark. Spanning approximately 18 kilometers, it's poised to become the world's longest immersed tunnel, designed for both rail and road traffic. The construction employs the use of specially designed ships to lay sections of the tunnel on the seabed, a method that underscores the innovative spirit of this undertaking. The tunnel comprises 79 individual segments, each meticulously fabricated off-site, showcasing the meticulous planning and precision that underpin this colossal project. The planned completion date for this project is unknown, but they're aiming to open it somewhere in 2029. While underwater tunnels are usually used for mobility, Canada is utilizing them for something else with their Seymour Capilano water filtration project. Nestled in the verdant landscapes of British Columbia, Canada, the tunnel is an engineering marvel designed to ensure the provision of clean, safe drinking water to the Vancouver metropolitan area. This project is distinguished by its expansive network of tunnels, stretching over 7.1 kilometers, which serve as conduits for transferring water between the Seymour Reservoir and the Capilano Reservoir. Constructed at a cost of over 600 million Canadian dollars, the project underscores the critical importance of sustainable water management in urban planning. The construction process showcased a blend of traditional tunneling methods and modern technological innovations. Two massive tunnel boring machines were deployed, each weighing over 1,000 tons, carving through the mountainous terrain with precision. The project became operational in May 2010, and ever since it has been a vital part of the region. But what about the most costly real estate development project in the United States? The Hudson Yards redevelopment project in New York City is a beacon of urban transformation, with an estimated total cost of over $25 billion. This colossal project has reshaped the west side of Manhattan, introducing a blend of high-rise residential buildings, office towers, and restaurants. One of the project's most innovative engineering feats is the platform built over the West Side Yard, a working train yard serving the Long Island Railroad. Constructed at a cost of approximately $1 billion, this platform covers 30 tracks, 3 rail tunnels, and 2 subway lines, all of which remain operational during construction. Another highlight is the vessel, a 16-story, honeycomb-like structure of interconnected staircases. Did you know the project includes a state-of-the-art waste management system designed to eliminate the need for traditional garbage trucks? This system, an investment in sustainability and efficiency, transports waste through a series of underground tubes to a central collection point. The development also prioritizes green spaces, with more than half of Hudson Yards dedicated to public plazas and gardens. A country that can obviously not be missing from this list is China, who has their own fair share of underwater megaprojects. Let's dive into the Hong Kong-Zhuhai-Macau Bridge Tunnel. Overcoming the physical and economic divide between Hong Kong and Zhuhai, this project was completed in October 2018. Consisting of a series of bridges and tunnels spanning approximately 55 kilometers, making it one of the longest sea-crossing structures in the world. With a budget exceeding $18.8 billion, the project is designed to facilitate the flow of people and goods, strengthening connectivity and economic integration within the Pearl River Delta region. At the heart of this colossal structure is a 6.7-kilometer underwater tunnel, descending up to 40 meters below the sea level, seamlessly connecting 2 artificial islands. This tunnel was a critical solution to avoid disrupting the busy maritime lanes in the Pearl River estuary. The construction of the tunnels required innovative engineering techniques, including the use of immersed tube tunnel methods for the underwater sections. It's time to travel to Pudong International Airport, which serves as a crucial hub in East Asia. Officially opened on October 1, 1999, This airport not only serves as a vital artery for international travel, but also stands as a symbol of modern engineering. With its strategic location in Pudong, Shanghai, it's designed to manage the demands of heavy passenger and cargo traffic, contributing significantly to the region's economic development. The airport's construction was a monumental project with an initial investment of approximately $1.67 billion for its first phase. This phase included the main terminal, a runway, and supporting transportation infrastructure, setting the stage for what would become one of the busiest airports in the world. The airport has since undergone several expansions, including the addition of Terminal 2 in 2008 and Terminal S1 for Spring Airlines in 2019, pushing its capacity and facilities to meet the growing demands of international travel. Covering an area of over 25 square miles, the airport features 5 total runways, with the latest opening in 2020, where it only had 2 runways before. This expansion was critical to accommodate the airport's increasing traffic, which saw over 76 million passengers in 2019, making it one of the top 10 busiest airports globally by passenger traffic. The terminal buildings are notable for their modern design, incorporating energy-efficient materials and systems. However, the airport's expansion has not been without challenges. The construction phases witnessed logistical challenges, including the coordination of a vast workforce and the seamless integration of new terminals and runways into the existing infrastructure without disrupting airport operations. These problems highlighted the complexities of executing large-scale infrastructure projects in a bustling urban setting. Pudong International Airport serves as a case study in modern airport construction, reflecting the challenges and achievements of building world-class infrastructure in the 21st century. Next up, it's time to visit one of the most expensive hotels in the United States. The Cosmopolitan in Las Vegas presents a fascinating study in both engineering achievement and financial investment. Opened in December 2010, this resort and casino complex was developed at a staggering cost of approximately $5.3 billion, making it one of the most expensive hotel projects in the world. A unique aspect of the Cosmopolitan's construction is its vertical design, a necessity dictated by the limited space available on the Las Vegas Strip. Standing at nearly 600 feet tall, these towers house over 3,000 hotel rooms, alongside a vast array of amenities including a casino, retail spaces, restaurants, and entertainment venues. Did you know that the project faced financial challenges during its construction, largely due to the economic downturn in 2008? This led to changes in ownership and a significant injection of additional funds to complete the project. Moreover, the Cosmopolitan is renowned for its emphasis on art and aesthetic appeal, featuring a multi-million-dollar art collection and striking design elements like the digital columns in its lobby. Stretching 54 kilometers, with a staggering 23 kilometers lying under the seabed, it connects the islands of Honshu and Hokkaido, piercing through the Tsugaru Strait. Completed in 1988 after nearly 2 decades of construction, the tunnel resolves the overcoming of geographical isolation and enhances connectivity. With an overall cost of approximately $3.6 billion, the Seikan Tunnel's construction presented formidable hurdles, including dealing with the seismic volatility of the region. The tunnel now serves as a critical link for passengers and freight trains, being one of the few ways to access the island. China is also exceptional at building high into the sky, and that's why we're taking a look at the Shanghai Tower. Rising majestically above the Lujiazui skyline, the Shanghai Tower was conceived with the dual purpose of symbolizing Shanghai's global financial prominence and pioneering sustainable urban living concepts. With its completion in 2015, the tower not only achieved its aim of being a financial center, but also became a model for future eco-friendly skyscrapers. The project, which began construction in November 2008, faced a lengthy development phase before reaching its completion 7 years later, reflecting the complex nature of constructing one of the world's tallest buildings. Costing approximately $2.4 billion, the Shanghai Tower stands as a financial behemoth, indicative of the massive investment in creating a landmark that merges architectural innovation with environmental stewardship. Spanning an area of 380,000 square meters, this 632-meter-tall skyscraper is not only a marvel of height, but also of space and design, featuring the world's second fastest elevators, which ascend at a speed of 18 meters per second. The construction of the Shanghai Tower introduced several innovative techniques and materials to address the unique challenges posed by its design. One of the most notable is its double-skin facade, designed to insulate the building and reduce the need for heating, thereby significantly cutting energy costs. This outer layer wraps around the building, creating a buffer zone that acts as thermal insulation, a feature that is critical in Shanghai's variable climate. The Shanghai Tower employs a unique twisting form, designed to reduce wind loads on the building by 24%. However, like many other megaprojects, the Shanghai Tower faced unique challenges during construction. Building such a massive structure in the densely populated area of Lujiazui posed potential problems, including traffic congestion and strain on local resources. Moreover, the financial viability of the project was questioned, with skeptics pointing to the high vacancy rates of office spaces in Shanghai and wondering whether the tower would become a vertical ghost town. As of 2019, 55 out of 128 floors sit empty, which is close to 50%. The next Chinese megaproject is truly stunning, being among the highest bridges in China. I'm talking about the Pingtang Bridge, positioned in the rugged terrain of Qishu province. Completed in December 2019, this bridge is pivotal for local development, reducing travel times and linking communities previously separated by challenging terrain. The bridge's design incorporates a hybrid approach, melding elements of both cable-stayed and suspension bridge technologies. This innovative strategy was chosen to address the unique challenges posed by the site, including high winds and the need for a long span without intermediate supports. The design features 3 main pylons, with the tallest standing at an impressive height of 332 meters. These pylons support the bridge deck with a series of stay cables, which are crucial for maintaining the structure's stability and distributing loads evenly. With a main span of 1092 meters and a total length of 2135 meters, the Pingtang Bridge is among the world's longest span bridges. It hangs approximately 332 meters above a river, making it one of the highest bridges globally. This engineering feat required a budget of approximately 1.5 billion yuan, or $215 million, reflecting the complexity and scale of the construction effort. Construction of the Pingtang Bridge was a logistical and engineering challenge. The remote location and difficult terrain necessitated innovative solutions for transportation and assembly of large structural components. The Chinese project team placed a strong emphasis on environmental conservation, implementing measures to minimize the bridge's impact on the surrounding ecosystem. Strategies included careful routing of the bridge to avoid ecologically sensitive areas and efforts to preserve the natural landscape. The California High-Speed Rail Project is an epic venture into modernizing transportation with an initial estimate of around $33 billion that has since soared past $100 billion. Designed to connect the state's major urban centers, such as San Francisco and Los Angeles, with speeds capable of reaching 220 miles per hour. The project aims to slash travel times to under 3 hours across approximately 800 miles of track. Projected to be the first of its kind in the country. A high-speed rail's completion date has been a moving target, currently anticipated for 2033. This timeline reflects the project's vast scope and the intricate engineering challenges it faces, including the construction of over 36 miles of tunnels through the Tehachapi and San Gabriel Mountains. An exemplar of sustainable transportation, the rail project is committed to operating on 100% renewable energy, with stringent environmental protections integrated into its development to minimize impacts on natural habitats. Despite facing financial scrutiny and logistical obstacles, such as securing adequate funding and navigating the complexities of state and federal regulations, the California high-speed rail continues to push forward. The Trans-Alaska Pipeline System, stretching approximately 800 miles, represents one of the most significant achievements in pipeline construction. Completed in 1977 at a cost of $40 billion, the project was constructed to transport oil from North America's largest oil field in Prudhoe Bay to the ice-free port of Valdez. One of the most notable is its earthquake-proof design, featuring sliding supports that allow the pipeline to move during seismic activity without rupturing. Approximately half of the pipeline is elevated on more than 78,000 vertical support members to prevent the thawing of permafrost, which could destabilize the structure. This design allows cold air to circulate around the pipes, helping to maintain the permafrost's integrity. Did you know that the pipeline system includes the crossing of over 800 rivers and streams? The project scale necessitated the largest private air force at the time to transport workers and materials, highlighting the logistical challenges overcome during construction. The pipeline can transport up to 2.1 million barrels of oil per day, showcasing its critical role in the U.S. energy infrastructure. While that tunnel might be long, it's time to visit a tunnel that's over 10 times as long. The Channel Tunnel, an engineering feat that bridged the UK and France beneath the English Channel, stands as a symbol of European unity and technological ambition. Completed in 1994 at a cost of £12 billion, this project was one of the most significant engineering projects of the 20th century. Spanning 50.45 kilometers, with 37.9 kilometers beneath the sea, the Channel Tunnel holds the record for the longest undersea portion of any tunnel in the world. The construction involved the use of 11 tunnel boring machines to carve through the chalk marl beneath the seabed. This Herculean task required unprecedented coordination between British and French construction teams. The tunnel comprises 3 separate tubes, 2 for rail traffic and a smaller service tunnel that acts as an emergency escape route. The use of precast concrete linings to reinforce the tunnel walls was a critical component of the construction strategy, ensuring the tunnel's durability and safety. Today, the Channel Tunnel is a vital link for commerce and travel between the UK and continental Europe, facilitating the seamless transit of millions of passengers and tons of freight annually. Let's go to the Louisiana offshore oil port, which stands as the only port in the United States capable of offloading deep draft tankers. Situated approximately 18 miles off the coast of Louisiana, the port plays a pivotal role in the import and export of crude oil, handling about 10 to 15% of the country's domestic oil. Built in 1970, the construction of this engineering feat was both a logistical and financial endeavor, costing over $300 million at the time, an amount equivalent to over $1.4 billion today when adjusted for inflation. Did you know that one of the most significant challenges during the port's construction was the laying of its underwater pipeline? This pipeline stretches over 48 miles to the onshore storage facilities and was one of the longest and most expensive underwater pipeline projects at the time. New York's LaGuardia redevelopment project has stepped it up even further, showcasing a radical transformation at a cost of over $8 billion. This monumental project not only aims to modernize the airport, but also to redefine the passenger experience with cutting-edge design and technology. At the heart of this project is the construction of new terminals, featuring over 1 million square feet of space designed to handle tens of millions of passengers annually. The redevelopment introduces a strikingly innovative dual pedestrian bridge design for Terminal B, allowing planes to taxi underneath. This is a pioneering concept designed to improve taxiway efficiency and reduce gate congestion, a crucial advancement given LaGuardia's limited footprint. Funding this colossal project involves a sophisticated financial structure, including $4 billion for Terminal B alone. Engineering feats within the project include the strategic demolition and phased construction to keep the airport fully operational. Moreover, the incorporation of more than 13,000 square feet of new pedestrian bridges enhances connectivity and streamlines passenger flow, showcasing an impressive blend of functionality and aesthetic appeal. Let's talk about the new Yankee Stadium, which opened its doors in 2009 in the Bronx. This modern cathedral of baseball came with a hefty price tag of approximately $3.3 billion, making it one of the most expensive sports venues ever built at the time. The stadium's design paid homage to the original 1923 Yankee Stadium, with its iconic facade and the replication of the original field dimensions. However, it introduced modern amenities and technology to enhance the fan experience. These included more than 50 luxury suites, high-definition video screens, and improved seating with greater legroom and sightlines. Did you know that the construction of the new Yankee Stadium required the demolition and redevelopment of Macomb's Dam Park? This aspect of the project added to its complexity and cost, as new recreational facilities had to be built to replace the parkland used for the stadium. The project's engineering efforts also addressed the challenge of building atop the New York City subway's elevated 4-train line, requiring careful planning to avoid disruptions. Let's transition to another underwater project that is connecting cities, called the Busan-Georgia Fixed Link. Spanning an impressive length of 8.2 kilometers, this fixed link connects the bustling city of Busan with the scenic island of Georgia in South Korea, serving as a vital artery that significantly reduces travel time. Constructed at a cost of approximately $800 million, the project was completed in 2010 after 5 years of relentless work. The fixed link is a hybrid structure comprising both bridges and underwater tunnels, ingeniously designed to navigate the challenges posed by the area's deep waters. The centerpiece of this engineering feat is a 3.7-kilometer immersed tunnel, one of the longest of its kind in the world, which plunges beneath the sea to allow ships to pass unimpeded above. Despite its successes, the project was not without its challenges. Environmental concerns were raised regarding the impact on the marine ecosystem, leading to stringent measures being implemented to mitigate damage. Financial obstacles also loomed large, with debates on the project's cost-effectiveness and the burden on public resources sparking rigorous discussions. It's time to visit Norway, which has constructed a crucial underwater project called the Ormen Lange gas pipeline. Spanning an impressive 1,200 kilometers, it connects the Ormen Lange field in the Norwegian Sea to the United Kingdom, specifically to the processing plant at Nyhamna, Norway. Commissioned in 2007, this pipeline plays a crucial role in securing energy supplies in the region, marking a significant achievement in the field of energy infrastructure. Constructed at a cost of over $10 billion, the Ormen Lange gas pipeline's engineering required innovative solutions to navigate the challenging deep water conditions of the Norwegian Sea, including depths of up to 1,100 meters. This project also stood out for its environmental and technical challenges, particularly the need to minimize impacts on the delicate marine ecosystem and address the harsh conditions found in the North Sea. The United States also has constructed some really impressive underwater megaprojects, such as the Chesapeake Bay Bridge Tunnel, stretching over the waters of the Chesapeake Bay to connect Virginia's eastern shore with the mainland. Opened in 1964 and expanded over the years, this 23-mile marvel is not just a bridge but a series of bridges, tunnels, and artificial islands. Constructed at a cost of approximately $200 million at its inception, with subsequent expansions adding to the investment, the Bay Tunnel stands as a testament to human ingenuity in overcoming geographical challenges. The structure includes 2 one-mile tunnels that dive beneath the bay, allowing ships to pass unimpeded above, while miles of low-lying trestle bridges provide breathtaking views of the surrounding waters. The use of the bridge-tunnel combination was a pioneering approach, providing a direct, uninterrupted flow of traffic across the bay and demonstrating a harmonious blend of functionality. Let's take a look at the South-North Water Transfer Project. Launched in response to the acute water shortages faced by the northern provinces, including the densely populated and economically pivotal Beijing-Tianjin-Hebei region. This mega-project aims to divert water from the Yangtze River in the south to the parched north through a series of canals, tunnels, and advanced pumping stations. Spanning over decades, with its inception dating back to planning stages in the late 20th century, the project is segmented into 3 distinct routes: the Eastern Route, the Central Route, and the yet-to-be-completed Western Route. Together, they have already transferred billions of cubic meters of water to the northern regions, substantially alleviating water stress in urban and agricultural areas. The financial scale of the South-North Water Transfer Project is staggering, with estimates of the total investment surpassing $80 billion. This figure underscores the complexity and the extensive scope of the project, which involves not only the construction of the physical infrastructure to facilitate the water transfer, but also significant environmental management measures to mitigate the impact on the ecosystems of both the source and recipient areas. The project features state-of-the-art tunneling techniques for crossing under major rivers and traversing diverse terrains, including mountains and urban areas. For example, the project utilizes some of the longest water conveyance tunnels in the world, with advanced boring machines to ensure minimal disruption to the surface. Additionally, it incorporates large-scale pumping stations equipped with high-capacity pumps to lift water across significant elevations along the routes. Furthermore, the project's design incorporates extensive measures for water purification and quality control, ensuring that the transferred water meets the stringent standards required for drinking and irrigation. However, the South-North Water Transfer Project is not without its challenges. The construction of the project's routes and reservoirs has necessitated the relocation of hundreds of thousands of people from their ancestral homes to make way for the infrastructure. This mass relocation has raised issues related to the resettlement process, including adequate compensation, preservation of cultural heritage, and the provision of new livelihood opportunities for those affected. Let's dive into Tianjin Eco-City, which is designed to house approximately 350,000 residents in an area covering about 19 square miles. The project emerged from mutual concerns over rapid urbanization, environmental degradation, leading to its initiation in 2008. The financial blueprint of the Tianjin Eco-City is as ambitious as its environmental targets, with investment figures projected to be near $10 billion, aiming to cover infrastructure, residential, and commercial development costs. This funding is directed towards not just constructing buildings, but also towards creating an integrated environment that supports sustainable living practices across energy use, water management, and waste disposal. One of the critical aspects of the Tianjin Eco-City is its emphasis on green building materials and advanced construction technologies. The city employs a variety of eco-friendly materials, including recycled concrete and sustainable timber. Innovative construction methods are utilized to ensure energy efficiency and resource conservation. These include the use of prefabricated parts to reduce construction waste and the implementation of smart technologies for water and energy management, showcasing a comprehensive approach to sustainable urban development. Despite its noble aspirations, skepticism arose over the feasibility of transforming a polluted, saline wasteland into a thriving eco-city. Concerns were also raised regarding the project's scalability and whether it could truly be replicated in other contexts, considering the significant initial investment and the need for technological innovation. The project encountered practical hurdles in attracting residents and businesses, crucial for the city's sustainability. The eco-city's location, distant from Tianjin's urban core, and the premium cost of living posed barriers to rapid population growth. This challenge highlighted the difficulty of balancing environmental goals with economic and social viability, a crucial lesson for future eco-city projects. Despite these obstacles, the Tianjin Eco-City continues to evolve, with ongoing construction and development reflecting both the challenges and potential of sustainable urban living. SoFi Stadium, nestled in the heart of Inglewood, California, represents a pinnacle of architectural grandeur in the realm of sports and entertainment venues. Completed in September 2020, it not only serves as the home for the NFL's Los Angeles Rams and Chargers, but also as a monumental achievement in stadium construction, boasting a final cost of approximately $5.5 billion. One of the hallmarks of its design is the immense canopy that covers the stadium and the adjacent plaza. Another standout aspect of the stadium's construction is its below-ground design. To comply with height restrictions near Los Angeles International Airport, the stadium was built into the ground, with its playing field situated 100 feet below ground level. This required extensive excavation work and sophisticated engineering to ensure stability, contributing significantly to the project's overall costs. Did you know that SoFi Stadium's video board, known as the Oculus, is another example of its unparalleled amenities? This double-sided 4K video board weighs approximately 2.2 million pounds and encircles the interior of the stadium, offering fans a 360-degree viewing experience that is as immersive as it is revolutionary. Our next underwater project is the only underwater research laboratory in the world, and it's called the Aquarius Reef Base, located in the United States. Anchored 62 feet or 19 meters below the surface near Key Largo, this remarkable facility offers scientists a unique aquatic vantage point for studying marine biology, underwater physiology, and the impacts of climate change on coral reefs. Established in 1986, Aquarius has facilitated groundbreaking research by allowing researchers to live and work in the ocean's depths for extended periods. The 400-square-foot habitat is equipped with living quarters, laboratories, and communication systems, enabling teams to dive deeper into their research without the daily decompression requirements that limit bottom time for surface divers. Being the only underwater lab in operation, the Aquarius Reef Base exemplifies human ingenuity in pursuit of scientific knowledge, turning the ocean's alien environment into a classroom. Let's move to the next impressive Chinese mega-project, called the Chongqing-Kunming High-Speed Railway. This pivotal project, stretching over 720 kilometers or 447 miles, connects two major cities in southwest China, Chongqing and Kunming. The railway, part of China's grand plan to create a 30,000-kilometer high-speed rail network, underscores the nation's ambition to lead globally in rail technology. Costing approximately 100 billion yuan or $15 billion, the Chongqing-Kunming high-speed railway is not just an economic investment but a technological showcase. The project features numerous tunnels and bridges, including the world-renowned Wulan Mountain Super Bridge. The railway reduces the travel time between Chongqing and Kunming from over 20 hours to just 4.5 hours, significantly impacting the social and economic landscape of the region. It enhances accessibility, promotes tourism, and fosters economic integration between the southwestern provinces. The construction of this railway employed cutting-edge machinery and materials, with a focus on durability and safety. High-strength steel, advanced concrete composites, and state-of-the-art track-laying techniques were utilized, ensuring that the railway could withstand the region's seismic activity. The use of tunnel boring machines and bridge-building gantries played a pivotal role in accelerating the construction pace, demonstrating China's prowess in leveraging technology for infrastructure development. One of the key challenges encountered during the construction was the environmental impact, particularly in ecologically sensitive areas. The project team implemented several mitigation strategies, such as rerouting sections of the track, constructing wildlife crossings over and under the railway, and implementing strict construction practices to minimize the disturbance to the natural landscape. But the project has not been without its controversies, including concerns over land acquisition and environmental degradation. The government and project developers have faced criticism over the lack of transparency and adequate compensation for those affected. Despite these challenges, the Chongqing-Kunming high-speed railway remains a symbol of progress and a critical component of China's vision for a modern country. The San Francisco-Oakland Bay Bridge Eastern Span replacement was completed in 2013. This project was initiated in response to the vulnerability exposed by the 1989 Loma Prieta earthquake. Its construction showcases a blend of architectural innovation and safety enhancements, with the final cost ballooning to approximately $8.6 billion, far exceeding initial estimates. One of the most striking features of the new Eastern Span is its self-anchored suspension design, a first of its kind for a single tower. This engineering marvel spans 247 feet and includes a main cable that loops around the roadway deck, anchoring it securely to itself rather than to the ground. Did you know that over 160,000 miles of wire were used to create the main cable of the bridge? Additionally, the bridge features a 525 feet tall tower, constructed with 4 steel legs linked by shear link beams designed to flex and dissipate seismic energy. Now it's time for a different type of underwater project, and for that we have to travel to the United States, where the Lake Mead Intake No. 3 tackles the critical issue of water scarcity. This monumental project, costing an impressive $817 million, was driven by the urgent need to secure a reliable water supply for Las Vegas, a city that depends heavily on the waters of Lake Mead. Initiated in 2008 and completed in 2015, the project involved drilling a 3-mile-long tunnel beneath Lake Mead, one of the largest man-made lakes in the United States. This was no ordinary task. It required the use of a 1,500-ton tunnel boring machine, cutting through the earth at depths reaching 600 feet below the lake's surface. The purpose: to construct a new intake capable of drawing water from the lake's depths, ensuring access to clean water even as lake levels fluctuated perilously low due to prolonged drought conditions. The construction of intake number 3 was not just about securing a water source, it was about innovating for the future. Engineers and workers faced the daunting challenge of working in an environment where temperatures soared, and the risk of flooding within the tunnel was a constant threat. Moving over to Seattle, it's time to talk about one of the priciest bridges in the country. The Evergreen Point Floating Bridge, also known as the SR 520 Bridge, stretches across Lake Washington to connect Seattle with its eastern suburbs. The bridge holds the title of the world's longest floating bridge, with a construction cost that soared to over $5.8 billion for the entire corridor project, highlighting the massive investment required. The bridge utilizes floating pontoons to support the roadway, a necessity due to the lake's depth and soft lakebed, which make traditional bridge foundations impractical. These pontoons are among the largest ever built, requiring precise engineering to ensure buoyancy and stability. Its construction involved not only the bridge but also the approach lanes and connecting roads, incorporating extensive environmental mitigation measures to protect the lake's ecosystem. Moreover, the bridge features state-of-the-art safety and traffic management systems, including wind speed sensors and a movable barrier system to optimize traffic flow. It's time to fly back to New York for the most expensive subway megaproject in the country. The East Side Access Project exemplifies the challenges and triumphs of urban tunneling and railway construction. With an estimated cost of over $11 billion, it ranks as one of the most expensive railway projects in the world. This ambitious project aims to connect the Long Island Railroad to a new terminal beneath Grand Central Terminal, offering a direct route that was previously unavailable to thousands of commuters. The East Side Access includes approximately 8 miles of tunneling beneath Manhattan's densely packed urban environment. These tunnels were not merely dug but meticulously carved through some of the most challenging geological conditions, including hard rock and water-bearing sediments. Did you know that the project necessitated the excavation of about 2 million cubic yards of rock? This is equivalent to filling the Empire State Building nearly 2 times. The construction also involves the creation of a new terminal beneath Grand Central, consisting of multiple levels of concourses and platforms. This terminal is being constructed more than 140 feet below street level, requiring innovative solutions for ventilation, lighting, and passenger flow. While the next underwater project may not be as big, the Poseidon Underwater Hotel is just as remarkable. This groundbreaking project, aiming to be nestled in the clear turquoise waters of Fiji, extends the frontier of hospitality into the aquatic realm. The hotel is designed to feature 25 suites, each encased in a 70mm thick transparent acrylic shell, providing 360-degree views of the vibrant marine ecosystem. With an estimated construction cost of $105 million, the hotel's ambition is not just to provide luxury but to pioneer an eco-friendly engineering. The structure is planned to be anchored at a depth of 40 meters below the sea level, covering an area of approximately 5,000 square meters. But an even more expensive megaproject is the Verrazano Narrows Bridge, an engineering marvel that connects the boroughs of Staten Island and Brooklyn and New York City. At the time of its completion in 1964, this bridge was the longest suspension bridge in the world. This colossal structure not only redefined the New York skyline, but also represented a significant financial undertaking, with a construction cost of approximately $3 billion. The bridge's construction necessitated not only a substantial upfront investment, but also a long-term financial strategy to ensure its sustainability. The bridge required thousands of workers and vast amounts of materials, including steel for the 260 feet long main span, which contributes significantly to the overall expense. Let's move on to an even more expensive megaproject in one of the biggest cities in the country, the Las Vegas Allegiant Stadium. Home to the NFL's Las Vegas Raiders and located right next to the famous Strip, this colossal structure was developed with a staggering construction cost of approximately $1.9 billion. But what makes this stadium worth that high price tag? Beyond its 65,000 seat capacity, the stadium features a retractable field and a massive translucent roof, offering fans a comfortable and visually stunning environment regardless of the desert heat. The Allegiant Stadium's construction also included a substantial investment in technology, with over 100 luxury suites and more than 8,000 club seats. But a truly stunning achievement is constructing the most expensive building in the United States. That's what Apple achieved with its Apple Park project, their futuristic headquarters located in Cupertino, California. Completed in 2017, this remarkable campus was constructed at an estimated cost of approximately $6 billion. Designed by the renowned architect Norman Foster, Apple Park is often referred to as the spaceship due to its circular, futuristic design. Spanning 175 acres, the main building covers 2.8 million square feet and accommodates over 12,000 employees. The construction of such a massive structure required one of the largest uses of curved glass for the building's exterior to achieve the seamless, minimalist aesthetic envisioned by Steve Jobs. A key focus of Apple Park's construction was its environmental impact. The campus operates on 100% renewable energy, featuring solar panels that generate 17 megawatts of power, making it one of the largest solar energy installations in the world on a corporate site. Did you know that the landscaping of Apple Park is as meticulously designed as the building itself? Over 9,000 drought-resistant trees were planted, creating a lush canopy that integrates the campus seamlessly into the surrounding environment. It's time to move on to one of the biggest pipeline megaprojects in the world, called the Nord Stream gas pipeline. Stretching beneath the Baltic Sea to connect Russia with Germany, this strategic pipeline operation since November 2011 spans approximately 1224 kilometers, making it one of the longest offshore gas pipelines in the world. With a total project cost estimated at 8.8 billion euros, the Nord Stream has capacity to transport up to 55 billion cubic meters of gas annually, playing a crucial role in ensuring energy security and diversification of supply routes in Europe. Constructed using state-of-the-art technology, the pipeline comprises two parallel lines, each made from tens of thousands of steel pipes, welded together onboard specialized vessels. These pipes, coated for corrosion resistance, were laid on the seabed by some of the world's most advanced laying ships, navigating through challenging marine conditions. Despite its technical achievements, Nord Stream has been mired in controversy. Critics argue that it increases European dependency on Russian gas, posing geopolitical risks. Environmental groups have also raised concerns about the potential impacts on the Baltic Sea's delicate ecosystem. Yet, proponents highlight its contribution to energy security and lower carbon emissions compared to coal and oil. It's time to visit the United Kingdom, where a tunnel is being constructed for an ambitious purpose. The Thames Tideway Tunnel aims to tackle London's over-a-century-old sewage system problem. Officially initiated in 2016, with an estimated completion by 2025. This massive undertaking is designed to prevent millions of tons of untreated sewage from entering the Thames River each year. Stretching over 25 kilometers and delving up to 65 meters below the river, the tunnel is a critical component of modernizing London's sewage disposal and treatment capabilities. Costing approximately £4.9 billion, the project is not just an engineering marvel but also a significant environmental initiative. By intercepting overflow from existing Victorian sewers, the tunnel will ensure that the Thames remains cleaner and more vibrant for future generations. Despite its environmental benefits, the Thames Tideway Tunnel has faced controversy, particularly regarding its financial impact on residents through increased water bills. The Central Artery Tunnel project, famously known as the Big Dig in Boston, Massachusetts, stands as one of the most complex urban infrastructure projects ever undertaken in the United States. Originally estimated at $2.8 billion, the project's cost skyrocketed to over $21.9 billion by its completion. Spanning from 1988 until 2006, the Big Dig aimed to address the chronic traffic congestion on Boston's Central Artery by relocating it underground and extending the Massachusetts Turnpike through a new tunnel under Boston Harbor. A key feature of the Big Dig was the construction of the Ted Williams Tunnel, the first major component completed in 1995, which extends I-90 to Logan Airport. Did you know that the project utilized over 3.8 million cubic yards of concrete, enough to lay a sidewalk 3 feet wide from Boston to San Francisco? The Leonard P. Zachem Bunker Hill Memorial Bridge is also part of this project, being the world's widest cable-stayed bridge, celebrated for its aesthetic appeal and structural design. Crossing the North Sea, it's time to visit Norway for a massive underwater mega-project. Norway's Coastal Highway project is an unparalleled infrastructure endeavor aimed at revolutionizing travel along the country's rugged western coast. With an estimated cost of $40 billion, this ambitious project seeks to eliminate the need for 7 ferry crossings by connecting the cities of Kristiansand and the south to Trondheim in the north through a continuous, ferry-free highway. Spanning over 1,100 kilometers, it involves the construction of bridges, tunnels, and causeways designed to navigate the challenging Norwegian underwater terrain and weather conditions. A highlight of the project is the proposed construction of the world's longest and deepest submerged floating tunnel, a feat of engineering that exemplifies Norway's innovative approach to overcoming geographical obstacles. This tunnel alone, part of the route across the Sognefjord, is expected to stretch 3.7 kilometers in length and reach depths of up to 392 meters below sea level. Scheduled for completion in 2050, the Coastal Highway project not only aims to significantly reduce travel time across the western coast, but also to boost economic growth and connectivity in remote regions. The Hoover Dam represents one of the most significant engineering achievements of the 20th century. With a total construction cost of over $2.7 billion, the dam's financial figures are as staggering as its physical dimensions. To construct the Hoover Dam, an estimated 5 million barrels of cement and 45 million pounds of reinforced steel were required. This was at a time when the procurement and transportation of such massive quantities of materials were incredibly challenging, contributing significantly to the overall cost. Moreover, the dam's construction provided employment for thousands of workers, offering a much-needed economic boost during a time of widespread unemployment. Did you know that the Hoover Dam also required the construction of Boulder City, a town built specifically to house the project's workers and their families? This added another layer of expense, but was essential for providing a stable and healthy living environment for the workforce. Let's fly over to Denver International Airport, which was completed in 1995 and was initially budgeted at $1.7 billion, but eventually soared to nearly $5 billion, reflecting the project's scale and the complexities encountered during its development. One of the most iconic features of the airport is its striking tent-like roof structure, designed to mimic the snow-capped Rocky Mountains and pay homage to Native American teepees. The construction of Denver International was fraught with challenges, leading to delays and cost overruns. One significant factor was the airport's advanced baggage handling system, which was one of the most sophisticated and automated systems designed at the time. However, its implementation proved problematic, causing operational issues that contributed to the airport's opening being delayed by 16 months. Did you know that the airport's runway system was designed to be the most efficient and flexible of any airport globally? Its layout allows for simultaneous takeoffs and landings in almost any weather condition, reducing delays and improving safety. How about a tunnel that has been connecting two countries for over 2 decades? Let's check out the Øresund Tunnel, which is part of the Øresund Link that connects Denmark and Sweden, facilitating unprecedented connectivity between the two countries since its completion in 2000. This project, with a total cost of around €4 billion for the entire Øresund Link, includes a bridge, an artificial island, and the tunnel itself, showcasing a blend of engineering ingenuity and cooperation across borders. Stretching 4 kilometers beneath the Øresund Strait, the tunnel complements the 8-kilometer bridge to form a comprehensive transport route. The construction of the tunnel employed the cut-and-cover method, where a trench was excavated on the seabed and prefabricated tunnel sections were then lowered into place. The Øresund Tunnel has significantly reduced travel time between Denmark and Sweden, bolstering economic ties and cultural exchange. But the underwater megaprojects can get much longer than that. The Baltic Pipe project was completed in 2022 at a cost of approximately €1.6 billion, and it stretches over 900 kilometers, forging a direct link between Norway's gas fields and Poland, with passages through Denmark. Its primary aim is to diversify energy sources and reduce Central and Eastern European countries' dependence on Russian gas, showcasing a pivotal shift towards sustainable and secure energy supplies. The construction of the Baltic Pipe involved laying underwater pipelines across the North Sea, a challenging endeavor that required advanced engineering techniques. Specialized ships were deployed to lay the pipes on the seabed, ensuring minimal disruption to commercial navigation routes. This project is notable not just for its engineering achievements, but also for its role in enhancing political cooperation among European nations. By providing a stable, reliable source of natural gas, the Baltic Pipe supports Europe's goals of energy independence and sustainability, relying less on Russia's Nord Stream pipe. The Woodrow Wilson Bridge project connecting Alexandria, Virginia, with Oxon Hill, Maryland, over the Potomac River, was reimagined to address the burgeoning traffic demands of the Washington, D.C. metropolitan area. The project's total cost, exceeding $3.4 billion, highlights its scope and the complexity of its execution. The decision to make the project a drawbridge, the world's second largest of its kind, was driven by the necessity to accommodate large ship traffic along the Potomac River. Moreover, the project expanded the bridge from 6 to 12 lanes, incorporating express and local lanes to significantly alleviate congestion. The addition of pedestrian and bicycle paths also reflected a forward-thinking approach to multimodal transportation. Let's travel to the Netherlands next for one of the most impressive underwater projects on the list so far. The Western Scheldt Tunnel, completed in 2003 at a cost of approximately €750 million, is not just a passage but a lifeline connecting the regions of Zeeuws-Vlaanderen and South Beveland, and significantly reducing travel time in the area. Spanning an impressive 6.6 kilometers, the Western Scheldt Tunnel holds the title of the longest tunnel in the Netherlands. Constructed using the immersed tube method, it consists of segments that were meticulously built on land and then submerged and connected beneath the Scheldt River. This construction approach required precision and innovation, including the use of GPS technology to ensure exact alignment of the tunnel sections. But the next underwater project is going to be a lot more feasible. The Gibraltar Strait Tunnel seeks to connect Europe and Africa, specifically Spain to Morocco, through a 14-kilometer underwater rail tunnel. This endeavor not only aims to bridge two continents, but also to significantly enhance economic and cultural exchanges between them. The project, with an estimated cost that could exceed $20 billion, is a testament to the potential of modern engineering to overcome geographical barriers. Construction of such a tunnel presents formidable challenges, from the deep waters of the Strait of Gibraltar, with depths up to 900 meters, to the seismic activity in the region. The proposed tunnel would be among the world's longest underwater tunnels, dwarfing existing ones in both ambition and technical complexity. Engineers are considering innovative boring techniques and special materials to ensure the tunnel's integrity and safety, taking lessons from other underwater projects like the Channel Tunnel between France and the United Kingdom. Now let's move to an underwater project that does not yet exist and that would break many records if it was being constructed. The transatlantic tunnel connecting New York to London is a testament to human ambition and engineering prowess. While not yet a reality, the concept alone pushes the boundaries of our current engineering capabilities and sparks discussions on the potential advancements required to make it possible. The envisioned transatlantic tunnel, stretching over 35 miles across the Atlantic Ocean's floor, showcases a blend of audacious goals and cutting-edge technology. Such a project would not only redefine international travel, cutting down flight times from 7 hours to just under an hour by train, but also represent a monumental leap in construction methodologies. Building this underwater passage would necessitate revolutionary materials and construction techniques capable of withstanding the immense pressures of the deep sea and the tectonic activities beneath the ocean floor. The cost, running into the trillions of dollars, and the construction timeline, spanning decades, reflect the project's unprecedented scale and complexity. The tunnel's conception involves massive, underwater tunnel boring machines and innovative materials for the tunnel structure, designed to endure the harsh conditions. Located in Lead, South Dakota, the Sanford Underground Research Facility is a pinnacle of science, situated a breathtaking 4,850 feet below the surface. This facility, which has repurposed the former Homestake gold mine, now serves as a forefront for scientific exploration shielded from cosmic interference. The transformation from a bustling gold mine to a sophisticated scientific research hub required an investment of over $600 million. At its operational peak, the Homestake mine produced approximately 40 million ounces of gold. The mine's extensive network of tunnels, which total over 370 miles, provides the necessary infrastructure for the project's deep underground science laboratories. The project initially faced significant opposition due to concerns over environmental impact and the stability of old mine workings. There were fears about water contamination and surface subsidence, which led to stringent regulatory reviews and the implementation of sophisticated water treatment facilities. The facility now houses multiple laboratories, where over 500 scientists from around the world conduct experiments. The depth of the facility provides over 4,850 feet of rock cover, which effectively shields the laboratory from about 99.5% of cosmic radiation that would otherwise interfere with sensitive experiments. Staying in the United States, let's visit the Delaware Aqueduct, renowned as the world's longest continuous underground tunnel. Spanning an extraordinary 85 miles from the Rondout Reservoir in the Catskills to the Hillview Reservoir in Yonkers, New York, this aqueduct is crucial, supplying about 50% of New York City's fresh water. It was constructed between 1939 and 1945, burrowing as deep as 1,500 feet beneath the Hudson River. Designed to transport roughly 600 million gallons of water daily, the aqueduct features a 13.5 feet diameter, lined entirely with concrete to ensure efficient water flow and structural integrity. The construction required the mobilization of 17,000 workers who faced the formidable challenge of excavating through solid rock and managing high-pressure water ingress. Innovative for its era, the project utilized both tunnel boring machines and traditional drilling and blasting methods. Operating under pressures that can exceed 200 psi, the structural design of the aqueduct was a complex undertaking. Engineers had to develop special concrete formulations and construction techniques to cope with the pressures equivalent to being 460 feet underwater. Initially costing about $160 million in 1940, which is about $2 billion today when adjusted. The Delaware Aqueduct's financial implications were significant. Beyond the immense cost, the project stirred environmental and social controversies, including the displacement of communities and substantial ecological impacts due to its construction. In terms of maintenance, the aqueduct has not been without its problems either. It suffers from leaks that lose up to 35 million gallons of water per day, necessitating a major repair initiative. A $1 billion project is currently underway, which includes the construction of a 2.5-mile bypass tunnel around the most severely affected section. Traveling across the globe, it's time to investigate an immense underground project in South Korea. Yulhyeon Tunnel, which is the deepest and longest double-track subway tunnel in the world, was completed in 2020 after extensive construction that began in 2011. The tunnel stretches a remarkable 50.3 kilometers, connecting the city of Yuewang with the town of Yulhyeon, and runs as deep as 50 meters underground at some points. The construction of the Yulhyeon Tunnel was a significant undertaking, costing approximately $1.2 billion. The tunnel's role in South Korea's transit infrastructure is pivotal. It facilitates the operation of trains traveling at speeds up to 110 kilometers per hour, which is expected to slash journey times between key South Korean cities by more than an hour. The tunnel's design and construction employed advanced tunnel boring machines and new Austrian tunneling methods, which are considered state-of-the-art in the field of tunnel construction. However, the construction of the Yulhyeon Tunnel was not without its challenges. The project faced significant engineering hurdles, including managing the immense water inflow and stabilizing the tunnel walls in sections with loose earth. In addition to technical challenges, the project also encountered regulatory hurdles. There were concerns about potential impacts on local ecosystems and water tables, which led to rigorous environmental assessments and the implementation of several mitigation measures to protect the surrounding environment. Moving over back to the United States, it's time to investigate the Soudan Underground Mine State Park. Nestled in the Vermilion Range of Minnesota, this project harbors the state's oldest and deepest iron ore mine, which commenced operations in 1882 and continued until 1962. This site has transitioned from a high-grade ore production facility to a hub for scientific research and public education. The mine's deepest sections extend nearly half a mile underground, setting it apart as one of the most substantial vertical shaft mines in the United States. During its 80 years of operation, the Soudan mine produced over 15.5 million tons of ore, a staggering amount that contributed significantly to the region's economic development. This production level was critical for the United States steel industry, particularly during both world wars. Transforming the site into Soudan Underground Mine State Park involved significant effort, with the state of Minnesota investing heavily to preserve this historical landmark. The transition included extensive renovations to stabilize old mine workings and adapt the underground tunnels for safe public tours and scientific research, specifically in physics. The park now hosts a state-of-the-art physics laboratory, which was established to study particle physics, including investigations into the elusive dark matter. This lab, located in the mine's lower levels, utilizes the Earth's natural shielding against cosmic rays to operate highly sensitive detectors, such as the MINOS experiment, which tracks neutrinos from the Fermilab in Illinois over a distance of 450 miles. It's time to travel to China for the Zhongnanshan Tunnel. Opened in 2007, it spans an impressive 18 kilometers, or 11 miles, making it one of the longest mountain tunnels globally. This dual-tube tunnel cuts through the heart of Zhongnan Mountain, reducing the travel time between Xi'an and Anqing from 4 hours to just under 2 hours. Excavating at depths of up to 1,640 feet beneath the mountain peaks, the tunnel presented unique geological challenges. The construction teams encountered a range of difficult conditions, from soft rocks and high groundwater inflow to hazardous gas emissions, each requiring bespoke solutions. The project's cost was estimated at approximately $470 million. One of the unique aspects of the Zhongnanshan Tunnel is its ventilation system. Given the tunnel's length and depth, maintaining air quality was paramount. The system is a pioneering effort in China for long tunnels, involving large ventilation towers that extract air from the center of the tunnel, ensuring the safety and comfort of motorists. This contrasts sharply with many older tunnels where simpler and less effective ventilation systems were implemented. Construction of the tunnel also set benchmarks in environmental conservation. The project included comprehensive measures to prevent damage to the local ecosystem, including relocating certain plant species and creating artificial waterways to redirect water flows altered by construction. In the tunnel's early years, it experienced problems with water leakage and ice formation in winter, posing risks to traffic safety. These problems were addressed through the retrofitting of the drainage system and the installation of an ice warning and response system, which have been critical in minimizing accidents and maintaining clear passage during the winter months. Traveling to Sweden next, it's time to look into one of the biggest mines in Europe. The Kiruna mine is not only the world's largest iron ore mine, but also one of its most profound, with operations extending up to 1,365 meters below the surface. This mine, which has been operational since 1898, annually produces over 35 million tons of iron ore, dwarfing smaller operations like the Iron Mountain Mine in California. Kiruna's expansive network covers an area of 174 square miles, making it larger than the well-known Carajás mine in Brazil. The mine's innovative use of automated drilling and haulage technology marks it as one of the most modernized mines globally. With over 310 miles of roads within the mine, Kiruna operates like an underground city. Its depth and scale necessitate a unique ventilation system capable of circulating approximately 1,200 cubic meters of air per second. The relocation of Kiruna's town due to mining-induced ground deformation is a distinctive aspect unmatched by any other mining project globally. This massive undertaking involves moving residential buildings and key infrastructures to a new site 3 kilometers east, ensuring the town's sustainability and the mine's expansion. The estimated cost of relocation tops €1 billion, highlighting the scale and economic impact of this project on the local community. The mine's strategic importance is underscored by its contribution to Sweden's economy, supplying over 90% of the iron ore produced in Europe. Next up is another underground Chinese megaproject called the Jinping Laboratory. This laboratory is the deepest underground lab in the world, located approximately 2,400 meters beneath the surface in the Jinping Mountain. This staggering depth surpasses that of other well-known underground facilities like the Sanford Underground Research Facility in the United States. Established in 2010, the Jinping Lab is designed for the detection of dark matter particles and other low-background experiments that require protection from cosmic radiation. The depth provides an overburden of 6,700 meters water equivalent, the highest of any laboratory in the world. Spanning an area of 2,000 square meters, the laboratory's construction involved excavating approximately 80,000 cubic meters of rock, a volume that underscores the massive scale of this project compared to smaller scientific setups such as the Gran Sasso in Italy. One of the unique challenges faced during the construction of Jinping was managing the high water pressure prevalent at such depths, which necessitated the development of specialized waterproofing and pressure management systems. The Jinping Underground Laboratory is also a site of international collaboration, drawing scientists from across the globe to its deep earth cavern. Moreover, the laboratory's remote location and depth make it a logistical challenge, requiring the transportation of equipment and personnel through a single tunnel that connects the lab to the outside world. But what about an impressive underground traffic tunnel located in the United States? The Port of Miami Tunnel project is designed to streamline traffic flow to Miami's bustling port facilities, while significantly reducing urban congestion on downtown streets. Completed in 2014, this $1 billion project introduced a 4,200 feet long twin-tube tunnel connecting the MacArthur Causeway on Watson Island with the Port of Miami on Dodge Island. With sections reaching depths of up to 120 feet below the Miami harbor, the Port of Miami Tunnel delves deeper than many other urban infrastructure projects, such as the Big Dig in Boston, which averages 65 feet deep. This depth was critical to allow unrestricted movement of cruise ships and cargo freighters, which frequent one of the busiest cruise ports in the world. The tunnel's construction utilized a world-class tunnel boring machine named Harriet, which was specifically designed for the Miami geology. This 42.3 feet diameter machine was one of the largest of its kind deployed in the United States. Financially, the tunnel project was structured through a public-private partnership, the first of its kind in Florida's history. The tunnel is equipped with state-of-the-art safety systems, including 91 CCTV cameras. These comprehensive measures surpass the setups found in smaller tunnels where budget constraints often limit such extensive safety implementations. Despite its successful completion, the Port of Miami Tunnel project encountered numerous challenges. Initial geological surveys underestimated the complexity of the Miami limestone, leading to adjustments in the tunneling work that delayed the project by several months. Moreover, the project's deep excavation close to densely populated urban areas and vulnerable marine environments posed significant logistical and environmental hurdles, necessitating rigorous compliance with stringent regulations. Moving away from the States, let's travel to South Africa for the world's deepest mine. Mponeng Gold Mine in South Africa reaches an astonishing 4 kilometers, or 2.5 miles into the Earth's crust. This operational depth exceeds that of any other mining venture globally, including the Tautona Mine, which extends 3.9 kilometers underground. Mponeng, which means look at me in the local Sotho language, began its operations in 1986 under Anglo Gold Ashanti and has since become a symbol of extreme engineering challenges. The mine's shafts and tunnels cover an area so extensive that it descends below sea level at points, creating a unique set of geological conditions. To maintain operations at such depths, the mine circulates ice slurry to cool the ambient temperature, which can reach up to 55 degrees Celsius due to geothermal heat from the surrounding rock. Producing over 244,000 ounces of gold annually, Mponeng's output is significant compared to smaller gold mining operations, such as the Porcupine Mine in Canada. A high-grade gold ore body at Mponeng is accessed through a complex network of tunnels and shafts, requiring highly sophisticated drilling and blasting techniques that utilize automated loaders and dump trucks for ore extraction and transportation. Mponeng's vast network of underground development is supported by a workforce of around 5,600 people, each of whom must descend a vertical distance greater than the height of Mount Everest to reach the working faces. The operational complexities of Mponeng extend beyond simple excavation. The mine deals with rock bursts and seismic activity due to the immense pressures at depth. These geological stresses are managed through meticulous seismic monitoring and advanced rock bolting techniques. Financially, the development and continuous modernization of Mponeng have seen billions of rand invested over the decades, including substantial sums spent on refining the gold extraction and processing facilities. But what about a gigantic underground sewerage system? Singapore's deep tunnel sewerage system is an ambitious underground wastewater management project designed to meet the country's water needs through the 21st century. Completed in 2008, Phase 1 of the project is a key component of Singapore's approach to sustainable water use, demonstrating foresight in urban planning and engineering. Spanning a length of 48 kilometers, the main tunnel of the system is situated up to 50 meters below the surface. This depth is considerably greater than many urban sewer systems, such as those in older parts of Paris or London, which are typically less than 30 meters deep. The tunnel's diameter is also impressive, stretching up to 6 meters across, capable of handling an immense 2.2 million cubic meters of wastewater daily, which is equivalent to 900 Olympic-sized swimming pools. The construction of Singapore's project was a technical challenge, involving the use of slurry shield tunnel boring machines to navigate through the varied geology of Singapore, from hard granite to soft marine clay. The project cost was approximately $2.7 billion, reflecting both its scale and complexity. A distinctive feature of the project is its integration with a comprehensive water recycling plan, where treated water is reclaimed and then purified further through advanced membrane technologies to produce NeWater, Singapore's brand of high-grade reclaimed water. However, the project was not without its difficulties. During construction, there were challenges related to the variable underground conditions, which required adaptive strategies to prevent disruptions. Additionally, the deep tunnel construction near urban areas posed risks of ground settlement, demanding constant monitoring and precise adjustment of tunneling operations. With plans for Phase 2 underway, which will extend the tunnel by another 100 kilometers, the system will continue to be a cornerstone of Singapore's water management infrastructure. Staying in Asia, we have to talk about Beijing's massive underground subway megaproject next. With its first line opening in 1969, the network has expanded to include 25 lines, encompassing over 700 kilometers of track and approximately 428 stations, making it one of the longest metro systems globally. This sheer size surpasses many other major systems, such as New York's subway, which measures about 380 kilometers in length. Diving into the depths, the Beijing subway's deepest point is at the Daxing Airport Express line, which reaches 30 meters below the ground. The construction costs for this colossal network have amounted to billions of dollars, with recent expansions like the Line 7 and Line 14 collectively costing over $7.3 billion. One unique aspect of the Beijing subway is its adaptation to the city's geological conditions, which include areas of high seismic activity. The system is designed with earthquake resistance features that allow it to withstand tremors, a critical capability not integrated into many older and less robust subway designs around the world. Moreover, the Beijing system incorporates state-of-the-art technologies such as contactless ticketing, high-speed train sets capable of exceeding speeds of 100 kilometers per hour, and an automated ventilation system that is considered one of the most advanced in the world. Challenges have been persistent throughout its development, including issues with overcrowding, particularly during peak hours where some lines see passenger loads far exceeding their design capacity. To combat this, the government has implemented dynamic pricing models during rush hours and has continuously expanded lines and added new ones to distribute passenger flow more evenly. As the system continues to grow, with plans to exceed 1,000 kilometers by 2030, it remains a critical component of Beijing's urban landscape. It's time to travel to Poland for the next project. The Wieliczka salt mine in Poland is an astonishing subterranean network that stretches to depths of up to 327 meters, or 1,073 feet below the surface, covering an expansive area of 2.4 million square meters. Operational for over 700 years since its inception in the 13th century, the mine is one of the world's oldest continuously running salt mines, only ceasing commercial salt production in 2007 due to flooding and the low price of salt on the global market. This historic mine features a labyrinth of tunnels, chambers, and galleries that extend over 178 miles, though only a small portion is accessible to the public. By comparison, the equally historic but much shallower Creer salt mine in Pakistan extends just 25 miles of passages. One of the mine's most unique attributes is its underground city, which includes chapels, a cathedral, and numerous sculptures all carved from rock salt by the miners. Financially, the development of Wieliczka salt mine over the centuries has involved significant investment, particularly in its conversion into a major tourism and health resort. The site now attracts approximately 1.2 million visitors annually, generating substantial revenue that supports its preservation and the local economy. Throughout its long history, Wieliczka has faced numerous challenges, including the threat of mine flooding, which on several occasions risked catastrophic collapses. These were mitigated through modern engineering efforts that included the installation of high-volume pumps and new drainage systems, ensuring the mine's stability and the safety of its visitors. Besides that, the preservation of this UNESCO World Heritage Site involves complex conservation practices. The saline environment, which is beneficial for health, poses a constant threat to the mine's structural integrity, accelerating the deterioration of wooden structures and necessitating continuous maintenance efforts. We travel to the country of Peru next, where the Almost Transandino project is located. Carving a 20-kilometer tunnel directly through the heart of the Andes Mountains and completed in 2006. This project represents one of the most ambitious underground endeavors globally, not just for its length but for its profound impact on the region's ecology and economy. Initiated to address severe water scarcity on Peru's arid Pacific coast, the tunnel channels water from the Huancabamba River on the Atlantic side of the Andes to the Pacific side. This engineering marvel plunges as deep as 2,000 meters below the mountain peaks, which is nearly 4 times deeper than the Channel Tunnel. The depth and complexity of tunneling through such diverse geological formations make the Almost Tunnel a standout project, far surpassing simpler ventures in both scale and technical challenges. Costing approximately $500 million, this project deployed one of the world's largest tunnel boring machines, nicknamed the Andean Giant. This machine faced unprecedented challenges due to the Andes' notorious seismic activity and the presence of tough silicified rock, which required custom-engineered cutter heads to break through. The tunnel now facilitates the transfer of 2 cubic meters of water per second, which is intended to irrigate 43,000 hectares of land, equivalent to the size of more than 60,000 football fields. Moreover, the Almost project has introduced an innovative water management system that includes not only the tunnel but also a vast network of canals and reservoirs designed to optimize water use across agricultural and energy sectors. The project's location in one of the most seismically active areas of the world required sophisticated geological surveys and adaptive construction techniques to mitigate potential earthquake damage. Despite this challenge, the completion of the Almost Tunnel has transformed a once parched region into one of Peru's most fertile agricultural zones. We travel to Saudi Arabia to inspect the Sindala Island project. Spanning approximately 840 hectares, Sindala will be an elite destination combining luxurious living with cutting-edge infrastructure. To put its size into perspective, it's roughly twice the size of Central Park in New York City. This extensive area is designed to accommodate around 2,500 luxurious hotel rooms, more than 800 residential properties, and a plethora of amenities including marinas, sports clubs, and retail establishments. Planned to be completed in 2024, the use of solar energy and cutting-edge water desalination plants are poised to set benchmarks in sustainable resort development. Furthermore, the architecture is designed to blend seamlessly with the natural environment, minimizing ecological footprint and enhancing the aesthetic value of the construction. Economically, Sindela is expected to create thousands of jobs, both during and after construction. The development is anticipated to contribute significantly to the kingdom's GDP, aligning with Saudi Vision 2032's goals of economic diversification and technological advancement. Sindela's marina is designed to rival the likes of Monte Carlo, featuring berths for over 400 yachts. Moving on, let's go to Indonesia next, where Nusantara, the future capital of Indonesia, is a groundbreaking megaproject set to complete its first phase in 2024. This ambitious endeavor aims to relocate the capital from the overcrowded Jakarta to Borneo's more geographically stable environment, spanning an area over 256,000 hectares, roughly 4 times the size of New York City. The relocation initiative is driven by Jakarta's susceptibility to flooding, congestion, and rapid sinking, which Nusantara aims to alleviate with state-of-the-art urban planning. Designed to be a smart city, Nusantara will incorporate sustainable practices such as green buildings, a central artificial intelligence system, and comprehensive public transport networks that minimize carbon footprints. Nusantara's infrastructure development is massive, with the government budgeting approximately $34 billion for initial phases. This includes constructing new government buildings, residential areas, and essential services, projected to host a population of 1.5 million people by 2045. The city's design emphasizes accessibility, aiming for residents to reach essential services within a 10-minute walk, markedly enhancing urban mobility compared to traditional cities. Unique to Nusantara is its energy blueprint, relying 100% on renewable sources. This includes solar farms and hydroelectric power, which contrast sharply with the coal-dependent energy production in other parts of Indonesia. Economically, the project is set to create over 100,000 jobs, with a focus on high-tech and green jobs, aiming to shift the economic balance from Java and stimulate growth in lesser-developed regions of Indonesia. While the size of Egypt's new administrative capital is similar, Nusantara's integration of environmental and digital technologies sets it apart as a model for future cities globally. The project includes plans for a central administrative district that is about 5,600 hectares. Transport infrastructure within Nusantara will be unparalleled, featuring autonomous vehicles and a ban on combustion engines within the city center. It's time to travel to the United Arab Emirates for the next project. Set to open its doors in 2024, the Zayed National Museum will be dedicated to the late Sheikh Zayed bin Sultan Al Nahyan, spanning across 12,000 square meters, roughly equivalent to 2 football fields. The museum's design, a masterpiece by the renowned architect Lord Norman Foster, features a cluster of 5 solar thermal towers soaring 125 meters high. These towers are not only architectural marvels, but also functional, acting as thermal chimneys to naturally draw cooling currents throughout the building. Zayed National Museum will host 9 permanent galleries, each narrating a part of the country's history. This space will also accommodate a temporary gallery space equal in size to an Olympic swimming pool, designed to host international exhibitions and large-scale installations. The building is poised to become a centerpiece in Saadiyat Cultural District, which also includes the Louvre Abu Dhabi and the upcoming Guggenheim Abu Dhabi. The construction utilizes materials that reflect the region's geology. The exterior is clad in limestone, much like the natural rock formations found in the Arabian deserts. Projected to attract around 300,000 visitors annually, the museum aims to double this number following the establishment phase. Staying in the same country, let's check out the Seal Tower, located in Dubai. Set to complete in 2024, it's poised to redefine the skyline as the world's tallest hotel. Soaring to a height of 365 meters, this architectural marvel will eclipse the current record holder, the Jevora Hotel, by over 30 meters. Designed by the acclaimed Noor Group, Seal Tower will house an impressive 1,042 luxury suites across its 82 floors. The building's floor area totals about 140,000 square meters, equivalent to roughly 20 football fields laid side by side. This expansive space is designed to accommodate not only guest rooms, but also an array of amenities, including multiple restaurants, a health spa, and a panoramic sky terrace. Seal Tower's construction incorporates more than 11,000 tons of steel, which is about 1.5 times the amount used in the Eiffel Tower. The use of glass in the facade covers approximately 40,000 square meters, providing clear, breathtaking views from every suite and public space within the hotel. Upon completion, Seal Tower is expected to attract around 3 million visitors annually. The investment in Seal Tower is substantial, with costs estimated to exceed $1 billion. In comparison to other global landmarks, Seal Tower's total usable height will be over 100 meters taller than the Shard in London, currently one of the tallest buildings in Europe. Additionally, the building will include an advanced fire safety system that exceeds the current Dubai civil defense codes, reflecting lessons learned from other high-rise fires in Dubai's history. Let's move over to Mexico next, where the Tren Maya project is set to be completed. The railway project, extending over 1,500 kilometers, will connect 19 stations and is expected to revolutionize transportation in southeastern Mexico. Tren Maya's construction involves laying enough tracks to stretch from Mexico City to Chicago, illustrating the project's vast scale. The train will serve both freight and passenger services, aiming to transport approximately 3 million passengers and a significant amount of goods annually once fully operational. The design includes a dual-track system for most of its route, allowing trains to travel at speeds up to 160 kilometers per hour, which will cut travel time between key cities by more than half compared to current road travel times. The project's budget, estimated at $15 billion, positions Tren Maya as one of the largest public works projects in Mexican history. Environmental considerations are integral to the project's design. The route is planned to minimize ecological impact, using existing transit corridors wherever possible to avoid deforestation in sensitive areas like the Mayan jungle. The trains are also expected to be powered by biodiesel, reducing carbon emissions compared to traditional diesel engines. Tren Maya is forecasted to dramatically increase tourism revenues by providing easier access to remote archaeological sites that are currently difficult to reach. This accessibility is anticipated to bring an additional 1 million tourists annually, potentially increasing tourism revenues by over $400 million per year. The construction phase alone has created approximately 100,000 jobs, and the operational phase is expected to support many more. Tren Maya's construction process utilizes advanced geological and hydrological engineering to protect the region's numerous cenotes and underground water reserves. Techniques include elevated tracks and special tunneling methods to prevent contamination or structural damage to these crucial environmental features. Traveling away from Mexico, we travel to Japan for a city megaproject. The country is set to unveil Woven City in 2024, a fully integrated smart city located at the base of Mount Fuji. This pioneering project, spearheaded by Toyota, covers an area of 175 acres, equivalent to about 100 football fields, and is designed as a living laboratory for futuristic technologies. Woven City's design incorporates 3 types of streets, one for faster vehicles, one for a mix of lower speed, personal mobility, and pedestrians, and one for pedestrians only. This segregation aims to optimize traffic flow and enhance safety in urban settings. Toyota plans to populate Woven City with 360 residents initially, mainly consisting of its employees and their families, with plans to expand the population to over 2,000 people including scientists, researchers, and tourists. The infrastructure of Woven City is another marvel, boasting a 100% sustainable energy supply, primarily through hydrogen fuel cells, a significant leap towards carbon neutrality. The building materials in Woven City will include traditional wood with a modern twist, incorporating robotic production methods to maximize durability and environmental efficiency. The use of wood aims to reduce the carbon footprint associated with concrete and steel construction. The city also integrates extensive green spaces, equivalent in area to nearly 25 Olympic-sized swimming pools, designed to improve air quality and provide residents with open, naturalistic environments. The city's waste management system will be highly automated, utilizing technology to sort and recycle waste, significantly reducing the per capita waste production compared to traditional cities. Transport within the city will include autonomous vehicles only, ensuring a safe and wholly integrated transport system. This aligns with Toyota's vision for a mobility company, transitioning from their traditional role as a car manufacturer. It's time to travel to France next, where the Olympic Games will soon take place. To accommodate for this massive event, the country is building the Paris Olympic venues designed not only to host the world's premier sporting event, but also to leave a lasting legacy on the city's landscape. These structures sprawl across several key locations in Paris, including the iconic Stade de France, which will serve as the main arena. This stadium is undergoing extensive renovations to accommodate over 80,000 spectators. The total budget allocated for the Olympic infrastructure, including both new constructions and renovations, is estimated at approximately 7 billion euros. This includes the development of the Olympic Village, which will cover an area of about 51 hectares. This space will later transform into 3,000 housing units, promoting sustainable living in the heart of the city. One of the most ambitious new constructions is the Aquatic Center, located adjacent to the Stade de France. This facility spans 15,000 square meters and features a temporary structure that can be dismantled post-Olympics. It includes an Olympic-sized swimming pool, a diving pool, and seating for up to 5,000 spectators. The construction workforce is another significant aspect, with over 30,000 workers involved in preparing all the venues. In terms of technology, the Paris Olympics will introduce the most extensive use of renewable energy sources among any prior Olympics. Solar panels installed across the venues are expected to generate at least 30% of the total energy requirement during the Games. The Grand Palais is being refurbished to host fencing and taekwondo events. The renovation emphasizes the enhancement of its Art Nouveau glass ceiling, increasing natural light and reducing the need for artificial lighting. The floor area here is being expanded to 72,000 square feet, about 1.5 times the size of the White House. The Seine River will also play a central role in the Games, with temporary venues for urban sports. Moving over to the neighboring country of Germany, we have to talk about the 4 Frankfurt project. This impressive development encompasses 4 towers, each designed to redefine urban living and working in Europe's financial hub. These 4 skyscrapers vary in height, with the tallest reaching 233 meters, making it one of the highest buildings in Germany, surpassed only by the Commerzbank Tower. Together, the towers boast a total floor area of approximately 218,000 square meters, equivalent to about 30 soccer fields laid flat. The construction budget for 4 Frankfurt is estimated at 1.3 billion euros. Around 5,000 construction workers are involved in bringing this project to fruition, utilizing approximately 50,000 cubic meters of concrete and 10,000 tons of steel, the latter amount enough to build 7 Eiffel Towers. Each tower's facade is designed with sustainability in mind, featuring high-efficiency glass that maximizes natural light while minimizing heat gain. This aspect is crucial considering the complex aims to achieve LEED Platinum certification. The residential units are expected to house about 1,000 people, providing them with amenities such as a panoramic gym, rooftop gardens, and direct access to a newly landscaped public plaza nearly twice the size of the Place de la Concorde in Paris. In comparison to other global megaprojects like Hudson Yards in New York City, 4 Frankfurt is unique in its approach to vertical living spaces and integration with public amenities. 4 Frankfurt's integration of office spaces in residential areas within the same complex is a model of modern urban development. The retail spaces within 4 Frankfurt cover 8,000 square meters, including high-end shops and culinary offerings that cater to both the residents and the broader public. Next up, it's time to visit China for the next megaproject. The Philharmonic Concert Hall, set to open its doors in 2024, is an architectural symphony in Beijing, designed by the renowned Mad architects. Spanning over 26,000 square meters, this state-of-the-art venue is poised to become one of the premier cultural landmarks in China. Constructed at a projected cost of $300 million, the hall demonstrates a significant investment in cultural infrastructure comparable to the Walt Disney Concert Hall in Los Angeles. The design features a vineyard-style auditorium with a seating capacity of 1,600 people, which allows every audience member to be no more than 30 meters from the conductor. Approximately 15,000 square meters of this unique material have been used, creating a visual effect similar to that of Beijing's iconic water cube from the 2008 Olympics. The project employs more than 3,000 workers and specialists, utilizing innovative construction techniques that include the use of robotic arms for precision tasks. This level of technological engagement in its construction is rarely seen in cultural buildings, and is more akin to the high-tech manufacturing processes used in skyscraper construction. Inside, the main concert hall is surrounded by rehearsal and recording studios, each designed with specialized soundproofing materials that cover a combined area of 2,000 square meters. The venue is also equipped with advanced digital streaming technologies that allow performances to be broadcasted worldwide, reaching audiences that are multiple times the hall's physical capacity. We have to travel back to France for a gigantic restoration megaproject. The restoration of Notre Dame Cathedral in Paris follows the devastating fire of April 2019, which led to the collapse of the cathedral's spire and significant damage to its roof. Spanning over 130 meters in length, Notre Dame is approximately the length of an Olympic swimming pool, emphasizing the monumental scale of the restoration work involved. The height of the spire, once rebuilt, will reach 93 meters. This restoration is expected to cost upwards of 850 million euros, sourced from global donations reflecting the world's shared interest in preserving this cultural monument. Over 1,000 craftsmen, artisans, and engineers are involved in the restoration, utilizing traditional techniques and materials consistent with the original construction. For instance, limestone from the historical quarries of St. Maximin is being used to match the texture and color of the original facade. The wood for reconstructing the forest, an intricate lattice of timbers that supported the roof, is being sourced from centuries-old oaks, just as it was in the 12th century. The complexity of the project includes the integration of modern safety and conservation technologies that were not present at the time of the original construction. Advanced 3D imaging and robotic technology are being employed to meticulously map and recreate architectural details that were lost or damaged. The roof's area, covering approximately 5,000 square meters, is being carefully reconstructed to mirror the original in appearance while integrating modern fire-resistant materials. This ensures that while the cathedral retains its historical aesthetic, it will not be susceptible to the same level of risk as before. The cathedral's famed organ, consisting of 8,000 pipes, is also undergoing an extensive cleaning and restoration process. Each pipe is being individually assessed and restored, a painstaking task that underscores the attention to detail central to this project. The expected completion in 2024 is set to coincide with the Paris Olympic Games, symbolizing a rebirth of both the cathedral and Parisian spirit. Next up, we move over to Taiwan, where the Kaesong Station project is well underway. This mega project, part of the larger redevelopment of Kaesong's transportation infrastructure, aims to connect the city more efficiently both locally and internationally. The new Kaesong Station covers a sprawling area of 8.5 hectares, roughly equivalent to 11 soccer fields laid side by side, making it one of the largest railway stations under construction worldwide. This expansive scale is designed to accommodate the station's role as a hub not only for rail travel but also for metro and bus services, integrating several modes of transport in one location. With a projected cost of over $1 billion, this station is a major investment in Taiwan's infrastructure, comparable in scope and ambition to projects like the Grand Paris Express in France. The station will include 15 tracks and 5 platforms, significantly increasing its capacity to handle up to 250,000 passengers daily, which is close to the capacity seen in London's Waterloo Station, Europe's busiest railway station. The construction of Kaesong Station involves over 4,000 workers, utilizing advanced building technologies including seismic isolators, which are critical in Taiwan's earthquake-prone environment. The station's interior will house a large art installation that reflects local culture and history, aiming to connect passengers with the heritage of Kaesong. But what about one of the tallest megaprojects ever built in Canada? The One, a skyscraper set to redefine Toronto's skyline, is scheduled for completion in 2024. Located at the intersection of Yonge and Bloor, This structure is designed to be Canada's tallest building at a height of 308 meters. Spanning 85 floors, the One features a mixed-use design that combines luxury residential units, high-end retail spaces, and boutique offices. The total floor space of the One covers approximately 416,000 square meters, an area large enough to fit 9 Canadian football fields. This ambitious project is being developed at a cost of over $1 billion, a financial commitment comparable to that of the Shard in London. The One employs over 1,600 construction workers and specialists who are utilizing over 45,000 cubic meters of concrete and 6,500 tons of steel. Mizrahi Developments, the firm behind the One, has collaborated with world-renowned architects Foster Plus Partners to create a unique structural identity through a pioneering exoskeleton design, both a functional and aesthetic element that eliminates the need for interior columns and opens up expansive, uninterrupted interior spaces. The retail levels at the One are elevated above the street, creating a two-story podium that integrates with the public realm. The One features 416 residential units, with each floor providing panoramic views of Lake Ontario and the city skyline. The building's top floors are reserved for penthouse suites, which include terraces that provide some of the highest private outdoor spaces in the city. We traveled to Australia next for a big metro expansion megaproject. The Sydney Metro expansion is an ambitious endeavour designed to dramatically enhance the public transportation network in Australia's largest city. This project extends the metro service into the Greater Western Sydney area and includes the new Sydney Metro City and Southwest Line. This expansive network will add 66 kilometres of new metro rail. The project comprises 18 stations, which when laid end-to-end, would stretch nearly 5 kilometers, long enough to cover the Golden Gate Bridge 1.5 times. The construction of this project involves more than 50,000 individual tasks, and the cooperation of over 5,000 workers at peak times. The budget for this monumental infrastructure project is estimated at $10 billion, making it one of the largest public transportation investments in recent Australian history. Key features of the expansion include twin 15.5-kilometer tunnels, which are among the longest railway tunnels in the world. To put that into perspective, this is more than 3 times the length of the Channel Tunnel that runs under the Thames in London. The stations themselves are feats of engineering designed for efficiency and integration with the city's existing transport fabric. Barangaroo Station, for example, is constructed 42 meters below ground level, which is as deep as a 12-story building is tall. Sydney Metro's new rolling stock will also set a new standard for public transport in the region. Trains are designed to be fully automated and driverless, featuring real-time route information and the capacity to move 40,000 passengers per hour in each direction, which matches the throughput of some of the busiest metro systems in the world, like those in Paris. But what about a project that renovates an entire stadium? The renovation of the Santiago Bernabéu Stadium, an iconic football venue in Madrid, Spain, is set to complete in 2024. This ambitious project enhances the stadium's facilities while preserving its historic significance as the home of Real Madrid since 1947. The project expands the stadium's seating capacity to over 81,000, slightly less than the Michigan Stadium, but with added luxury and technology. The total cost of the renovation is estimated at around €800 million, funded entirely by the club without public money. The Bernabeu's new roof spans 160 meters at its widest point. This retractable roof can open or close in just 15 minutes, ensuring events proceed regardless of weather. The development's glass facade wraps around the stadium, integrating it seamlessly into the cityscape and reducing the architectural boundary between the stadium and Madrid. The Santiago Bernabéu will also feature a new pedestrian plaza covering 20,000 square meters on the Paseo de la Castellana. Inside, the renovations include cutting-edge technology with the installation of a 360-degree video scoreboard, a first for European stadiums. Furthermore, the stadium's interior will house a new Real Madrid museum, which is expected to be twice the size of the FIFA Museum in Zurich. The new Burnaby is equipped with solar panels covering 10,000 square meters, capable of generating enough energy to power 400 homes. This initiative not only aligns with global sustainability goals, but also sets a new standard for sports facilities worldwide. Moving back to Canada, we have to talk about the LNG Canada project. Situated in Kitimat, British Columbia, this liquefied natural gas facility is pivotal to Canada's energy export ambitions, positioning the nation as a key player in the global LNG market. This sprawling project covers a site of approximately 400 hectares, about the size of 560 soccer fields, demonstrating the massive scale of this endeavor. The facility is designed to initially process around 14 million tons of LNG per year, with plans to expand to 28 million tons in its later phases. This output capacity is equivalent to supplying approximately 70 million homes with energy annually. The total investment for the LNG Canada project reaches approximately 40 billion Canadian dollars, a figure that surpasses the cost of constructing the recent large-scale Gorgon LNG facility in Australia. LNG Canada's environmental strategy features cutting-edge technology that reduces carbon emissions by approximately 35% compared to other LNG plants worldwide. This facility uses renewable hydroelectric power for its operations, distinguishing it from others that typically rely on natural gas for liquefaction processes. Another unique aspect of the LNG Canada project is its shipping logistics. The facility includes a newly built terminal capable of accommodating the largest LNG carriers currently in service. These vessels are about 300 meters long, nearly as long as the Eiffel Tower laid down, which allows for efficient transport of LNG to markets across the Asia-Pacific region, where demand for cleaner energy solutions is rapidly growing. The project is expected to generate roughly 22 billion Canadian dollars in direct government revenue over the next 40 years through taxes and royalties, enhancing public services and infrastructure development across Canada. We have to travel back to Australia for the next gigantic project, which is called the Melbourne Metro Tunnel. This crucial development aims to enhance the capacity and efficiency of Melbourne's rail network, addressing the critical need for an urban transit solution to accommodate the city's growing population. Stretching 9 kilometers in length, the Metro Tunnel features twin tunnels, each approximately 7 meters in diameter. The construction involves the use of over 600,000 cubic meters of concrete, enough to fill 240 Olympic-sized swimming pools, and reinforcing it with 70,000 tons of steel. With a total cost estimated at $7 billion, the Melbourne Metro Tunnel is one of the most significant public transport investments in Victorian history. One of the most innovative aspects of the Metro Tunnel is its 5 new underground stations, which are strategically located to maximize accessibility and integrate seamlessly with Melbourne's existing transportation grid. The project includes comprehensive measures to minimize its carbon footprint, such as energy-efficient systems and the use of recycled materials wherever possible. The tunnel's construction utilizes advanced slurry shield tunneling machines that reduce the surface disruption typically associated with subway construction. Moreover, the Metro Tunnel will increase the network's service capacity by 45%, facilitating smoother and faster travel across the city and reducing congestion in the CBD by up to 15%. This enhancement is akin to adding an extra freeway into the city, but without the accompanying environmental toll of increased vehicle emissions. Let's move over to China for an extremely tall dam. The Bayon Dam, located on the Qishu River, is one of the most formidable hydroelectric power stations in the world. At a height of 289 meters, this arch dam has the capacity to produce a massive 16,000 megawatts of power through its 16 turbines. Designed for more than just power generation, Bayon also plays a crucial role in flood control, irrigation, and river navigation enhancement. It creates a reservoir that holds 20.6 billion cubic meters of water, almost double the volume of Lake Mead, the largest reservoir in the United States. Upon completion, Bayon Dam has significantly bolstered China's renewable energy portfolio, aligning with the country's ambitious goals to reduce reliance on coal and cut carbon emissions. It serves as a critical element in China's West-East power transmission strategy, which aims to supply the eastern regions with clean, renewable energy generated from the western provinces. Crossing the globe, we travel to the United Kingdom for the tallest building in the country. The Shard rises majestically to a height of 310 meters, making it the tallest building in the country and the fourth tallest in Europe. Its 95 stories are encased in 11,000 glass panels, covering a total surface area of 56,000 square meters, which is enough to cover 8 football pitches. This neo-futuristic skyscraper, completed in 2012, was designed by the renowned Italian architect Renzo Piano, who envisioned it as a vertical city. The Shard houses offices, luxury residences, a 5-star hotel, and multiple top-tier restaurants, all offering panoramic views of London. The construction of the Shard was a monumental task, utilizing 243,000 cubic meters of concrete and 36,000 tons of steel. This structural marvel can accommodate up to 85 people at any one time, roughly equivalent to the population of a small town. Visitors can ascend to the observation deck, located on the 72nd floor, which offers an unrivaled 360-degree view of the city, stretching up to 64 kilometers on a clear day. The Shard's dynamic facade reflects the changing skies, seamlessly integrating the building into the fabric of London while minimizing heat absorption through its energy-efficient glass. Staying in Europe, we travel to Paris for the world-famous Eiffel Tower mega-project. When completed in 1889 for the Exposition Universelle, it was the tallest man-made structure in the world, standing at 324 meters high. Constructed from 7,300 metric tons of iron, the Eiffel Tower comprises 18,038 individual metal parts, joined together by 2.5 million rivets. This engineering marvel was designed by Gustave Eiffel, whose firm specialized in constructing bridges. Remarkably, the Eiffel Tower was intended to be dismantled in 1909, but was spared due to its utility as a radio telegraph station. Today, it attracts more than 7 million visitors annually, making it the most visited paid monument in the world. The tower's 3 levels are accessible to visitors, with restaurants on the first and second levels and the highest observation deck accessible at 276 meters. Each of the Eiffel Tower's 4 pillars rests on slabs of limestone with foundations sinking down to depths of about 7 to 15 meters, an architectural necessity that supports the massive iron lattice structure. The Eiffel Tower's iconic silhouette has inspired numerous replicas worldwide, but none match the original's architectural elegance and historical significance. Traveling to the opposite side of the Earth, we pay a visit to New Zealand. Standing at a commanding height of 328 meters, the Sky Tower in Auckland is not only the tallest freestanding structure in the Southern Hemisphere, but also an engineering and telecommunications beacon. Its height surpasses the Shard in London, underscoring its prominence on the global stage. Constructed using 2,000 tons of steel and 15,000 cubic meters of concrete, the Sky Tower serves as a critical link in New Zealand's telecommunications network, featuring 21 transmission antennas. The Sky Tower can withstand wind speeds of up to 200 kilometers per hour, and earthquakes with a magnitude of up to 8.0 on the Richter scale, owing to its deeply secured foundation which penetrates 15 meters into the earth. The Sky Tower's lighting, which uses energy-efficient LED bulbs, often changes color to support charitable causes, intertwining functionality with community engagement. Making our way back to France, it's time to talk about the Millau Viaduct. Soaring to a height of 343 meters, it holds the title of the world's tallest cable-stayed bridge. The viaduct spans 2,460 meters with the longest single span reaching 342 meters and a deck width of 32 meters. It features 7 concrete piers, with the tallest pier standing at 245 meters high, which is more than twice the height of the Statue of Liberty from base to torch. The bridge was designed by the British architect Norman Foster and French structural engineer Michel Verlojux. The construction, completed in just 3 years and opened in 2004, aimed to alleviate summer traffic congestion on the route from Paris to Spain, which it has successfully done by shortening travel time by several hours during peak periods. The viaduct not only serves a practical transport function, connecting the Clermont-Ferrand to Béziers and Montpellier, but also acts as a tourist attraction in its own right. Approximately 20,000 vehicles cross the viaduct each day, and its construction has boosted local economies by increasing accessibility and reducing transportation costs. It's now time to check out the Petronas Twin Towers in Kuala Lumpur, Malaysia. Reaching a staggering height of 452 meters, this project is the tallest twin structure in the world and surpasses the Willis Tower in Chicago by 10 meters. These architectural marvels held the title of the tallest buildings in the world from 1998 to 2004 until surpassed by Taipei 101. Constructed using 33,000 tons of steel and 160,000 cubic meters of concrete. Each tower is supported by a 120-meter deep foundation, which is among the deepest for any building. The design, a brainchild of Argentine-American architect Cesar Pelli, was inspired by traditional Islamic art reflecting Malaysia's cultural heritage, with a floor plan based on an 8-pointed star. The towers are linked by a double-decker skybridge at the 41st and 42nd floors, which is the highest two-story bridge in the world. Featuring 88 floors of office space, the towers house the headquarters of Petronas, Malaysia's national petroleum corporation, as well as other corporations. The construction of the Petronas Twin Towers employed a cutting-edge curtain wall system that is designed to reduce heat and enable energy-efficient cooling. But the towers can get much taller than that. Next up is Landmark 81, soaring majestically over Ho Chi Minh City, Vietnam. It reaches a towering height of 461 meters, making it the tallest building in Vietnam and among the top 20 tallest worldwide. The building consists of 81 floors and covers a floor area of 241,000 square meters, used for a mix of residential, retail, and leisure facilities, making it a multifunctional vertical city. Its design is inspired by the bamboo stalk, a symbol of traditional Vietnamese resilience and elegance. Landmark 81 boasts a luxury hotel, high-end apartments, and Vietnam's highest observatory deck, offering panoramic views of the city and the Saigon River. The development was completed in 2018 by the Vingroup conglomerate, with a design by the renowned architectural firm Atkins. The tower is part of a larger $1.5 billion Vinhomes Central Park development project, which aims to transform the city's skyline and elevate its international profile. Strategically positioned along the banks of the Saigon River, Landmark 81 is not only a commercial and residential hub but also a beacon for eco-friendly practices, featuring vertical gardens and sustainable architecture elements. It's time to travel to the seas now for the Trolla platform, located in the North Sea. At 472 meters tall, it is not only the tallest structure ever moved by mankind, but also surpasses the Petronas Twin Towers in height. This gas production platform is primarily stationed in the Troll gas field, about 80 kilometers northwest of Bergen, Norway. Constructed with prodigious dimensions, Troll A's total weight is over 1.2 million tons, including ballast, a mass greater than the heaviest man-made objects ever moved. The platform's legs are each 1.2 meters in diameter, extending 303 meters below the sea level into the seabed. Commissioned by Statoil, the platform began operations in 1996. Remarkably, it features accommodation to house up to 200 workers who manage its daily operations. The deck carries all the equipment necessary for drilling and gas extraction, arranged to maximize efficiency and safety. The platform's elevation above the water is 369 meters, which is taller than the Eiffel Tower, providing a stark perspective on its monumental scale. Troll is also equipped with cutting-edge technology to handle daily gas production of about 83 million cubic meters, the high efficiency of which underscores Norway's leading role in the global energy sector. Let's travel to Russia next to inspect the Ostankino Tower, located in Moscow. Completed in 1967 during the Soviet era at a height of 540 meters, the Ostankino Tower was designed primarily for telecommunications and to mark the 50th anniversary of the October Revolution. It holds the distinction of being the first structure outside the United States to exceed 500 meters in height. The tower's construction incorporates over 55,000 cubic meters of concrete and 3,000 tons of steel, a testament to Soviet engineering prowess. Ostankino's antenna allows for broadcasting television and radio signals across a 1,000-kilometer radius, covering an immense swath of Russia's populace. It is equipped with multiple observation decks and a revolving restaurant, offering panoramic views of Moscow, making it a significant cultural and tourist attraction. The tower's fire in 2000 led to extensive renovations, including the installation of advanced fire safety systems, ensuring its resilience and safety for future generations. Ostankino's unique lattice structure is not only functional but also iconic, designed to withstand severe Russian weather conditions and seismic activity. Next up, it's time to have a look at the world-famous One World Trade Center. Also known as the Freedom Tower, it stands as an indomitable pillar in the New York skyline at a patriotic height of 541 meters, including its spire. This makes it the tallest building in the Western Hemisphere, surpassing the Willis Tower in Chicago by 124 meters. Its 104 stories are encased in a shimmering facade of 2,000 pieces of prismatic glass, designed to reflect the sky and refract light, representing hope and endurance. One World Trade Center's design incorporates a reinforced concrete base, clad in blast-resistant materials, spanning 57 meters high, which is unprecedented in scale for such safety features. Above this base, office floors begin, featuring floor-to-ceiling windows that offer unobstructed views of Manhattan. The building's total floor area spans 3.5 million square feet, accommodating businesses, restaurants, and broadcast facilities. Its observation deck, located on the 100th to 102nd floors, provides visitors with breathtaking 360-degree views of New York City. Staying in North America, let's talk about the CN Tower, located in Toronto, Canada. At 553 meters, this icon was the undisputed tallest freestanding structure in the world from its completion in 1976 until 2007. Imagine standing atop the Sky Pod deck. At 447 meters, you're taking in views that stretch over 160 kilometers on a clear day. Designed to endure the fierce Canadian elements, it incorporates 40,500 cubic meters of concrete and over 4,500 tons of steel. This robust construction is designed to withstand wind speeds of up to 418 kilometers per hour and is equipped with a sophisticated lightning attraction system that handles around 75 lightning strikes per year. Function meets form with the tower's practical use as a key telecommunications hub for Toronto. It broadcasts radio and television services across the cityscape, proving that this landmark isn't just for show, it's an integral part of daily life in Toronto. The journey up can be as thrilling as the view. In one of 6 high-speed elevators, ascend at a rate of 22 kilometers per hour to the main pod, which features not only the glass floor, but also a revolving restaurant that offers a 360-degree sweep of the city below over a 72-minute rotation. It's time to travel to South Korea next. Rising majestically above Seoul, the Lot World Tower stands as a pinnacle of architectural innovation and the tallest skyscraper in South Korea at 555 meters. Surpassing the One World Trade Center by 14 meters, it is ranked as the 5th tallest building globally. Designed to withstand the challenges of extreme weather, Lot World Tower features a sleek, tapered design that minimizes wind pressure, a necessity in its lofty position above the bustling city. The structure is built with over 52,800 cubic meters of concrete and supported by a weighty 430,000 tons of steel, amounting to more than the iron used in the Eiffel Tower. Lot World Tower also features the world's fastest double-decker elevators, known as Sky Shuttle, which can travel from the ground floor to the 121st floor in 1 minute, reaching speeds of 600 meters per minute. But what about the tallest clock tower in the world? Perched next to the Grand Mosque of Mecca, the Abraj al-Bayt Clock Tower isn't just a skyscraper, it's a colossal marvel towering at 601 meters, making it one of the tallest and most striking man-made structures on Earth. Its clock face, the largest in the world, spans 43 meters in diameter, easily outclassing London's Big Ben by 5 times. Built at a staggering cost of $15 billion, this megastructure is part of a 7-tower complex that redefines luxury and scale. Above, a 93-meter-tall spire topped with a 23-meter golden crescent makes it a beacon visible from miles across the city, guiding pilgrims like a lighthouse of faith. With the world's largest floor area, the tower hosts an Islamic museum and a moon observation center which provides astronomers and scholars a unique vantage point for sighting the moon, crucial for the Islamic calendar. It's time to travel to the United States for the tallest mast on planet Earth. The KVLYTV mast, towering at 629 meters, stands as the tallest structure in the Western Hemisphere and the tallest guide mast in the world. Erected in 1963 near Blanchard, North Dakota, this engineering feat surpasses the height of other monumental structures like Tokyo Skytree and Shanghai Tower when considering guide masts alone. Engineered to enhance broadcast range, the mast extends television coverage across the eastern North Dakota and northwestern Minnesota plains. It utilizes approximately 30 kilometers of guy wires, which are anchored in 3 directions to stabilize the structure against the formidable winds typical of the Great Plains. Constructed with high-strength steel, the mast weighs around 9,000 pounds at its pinnacle, despite its towering presence. The mast's foundation is embedded deeply into the earth, ensuring structural integrity and resistance to torsional forces caused by harsh weather. Visibility of the mast from great distances requires aviation safety measures, including numerous red warning lights along its length, to alert aircraft. It's time to visit Tokyo next for the Tokyo Skytree. Towering at 634 meters, it was completed in 2012 to serve as a primary television and radio broadcast site for the Kanto region, ensuring clearer transmission as high-rise buildings proliferated. Constructed with about 36,000 tons of steel, Tokyo Skytree features a unique seismic proofing design with a central concrete column independently secured from the surrounding steel frame. A method inspired by ancient pagodas which allows the structure to withstand earthquakes with minimal sway. The tower's color, officially called Skytree White, is based on a traditional Japanese indigo blue hue, blending modern design with traditional aesthetic considerations. The lighting of the Skytree alternates between the Iki sky blue and Miyabi purple, inspired by the patterns of Japanese folding fans, which illuminate the tower beautifully at night. Tokyo Skytree has 2 observation decks at heights of 350 meters and 450 meters, offering panoramic views of Tokyo and, on clear days, Mount Fuji. The base of the Skytree is a bustling commercial hub named Tokyo Solamachi, which includes over 300 shops and restaurants. But the absolutely tallest structure on planet Earth is of course the Burj Khalifa, located in Dubai. Completed in 2010 at a height of 828 meters, the superstructure took more than 22 million man-hours to build. The tower features 163 floors above ground, including corporate suites, residences, and the Armani Hotel. It also boasts the highest observation deck in the world, located on the 148th floor at 555 meters. Hosting the world's second highest swimming pool on the 76th floor and the world's highest restaurant on the 122nd floor. The Burj Khalifa is not only a feat of engineering but also a luxury destination for global tourists. The project is also pivotal for technological innovations such as the telescopic spire comprising more than 4,000 tons of structural steel. Given its height, the Burj Khalifa is designed to withstand Dubai's hot summer temperatures with its reflective glazing, and the exterior temperature at its top is significantly cooler than at its base.